Hello folks, welcome back to another Impl Rust stream. It's been quite a while since we did one of these. It's been a bunch of Q&A streams, some shorter streams, but I really wanted to go back to just like writing a bunch of Rust code over a few hours. And so that's what we're going to do today. I spent a bunch of time thinking like, what do I want to do? And there were a lot of good suggestions on the Discord. When you're like any of the supporter tiers, you get access to a channel where you can like suggest stream topics. There are a bunch of good topic suggestions in there, and I got some on Mastodon and stuff too. But I actually wanted to do something a little different today, which is I wanted to kind of code something that's not very serious, for the lack of a better word, right? Like, I feel like a lot of the things we end up building in these streams are like, you know, implementing TCP, like it's a lot of protocol spec and figuring out how that thing work, or like reporting flame graph. There's a lot of like really weird, intricate code for manipulating stack traces, or with the port of the concurrent hash map from Java, right? Like that's like heavy atomics code. And that I understand that is interesting to learn from, right? It gives a lot of detail and in-depth analysis, but sometimes I just kind of want to write some, not straightforward Rust, but just like something that isn't intellectually that hard, but it's just like, we just have to write a bunch of Rust code. The Code Crafter streams have been a little bit like that, but they're still very problem oriented. Whereas here, I wanted something that was more outcome oriented. Like I just want to build a thing that is going to be kind of fun to build and also maybe is useful. And so I found this tool called guff, which I've had in my bookmarks for ages to just like play around with. And I never have. I've literally never run this program, but I like the idea of it a lot. And I also notice that its last commit was 9 years ago and is written in plain C, which sounds like a good, candidate for, let's try to write it in a different language to see what it's like. This is a command line tool that takes a bunch of numbers on its input and then it plots them to your terminal in ASCII text. And this is something that I end up doing quite a lot. Like I want something like this. I very often end up piping things like into GNU plot or into like R script, where then I then put like a -E to get summary statistics and stuff. And that works, but I'm just like, I want something that just does kind of the right thing. Like it just does something reasonable. And I think we could always extend on this. So this lets you give like X and Y coordinates like this. So you can plot X and Y, or you can just give the Y coordinates and it just plots, from X equals 1 and onwards. And like it's just literally just reads input like this and then plots it, which is super handy. But I think we could possibly expand this a little bit to do things like plot the CDF, so the cumulative distribution function, or the PDF, the probability density function. So that if you have data, you can get like statistical analysis over that, maybe by running HDR histogram or something behind the scenes. Like there's a bunch of ways in which this could be made like slightly more powerful, even for relatively simple inputs, that I feel like you end up generating quite a lot when you work on the terminal. Like these kinds of command lines, I write a lot, right? Of like I grep for something, I sort, I awk something out, maybe I said something, and then I just want to see like, I end up with a bunch of numbers and I want to see just a plot of them, or quite often I want like summary statistics, right? Like I want the median, I want the mean, and I want like a histogram with buckets or something, or at least like the 95th percentile and stuff. And I feel like we could actually incorporate this into a tool pretty easily. So that was one of the reasons why I wanted to do guff. The other reason I wanted to do guff is because it is a C program, and I feel like we've ported from Perl, we've ported from Java, right? Perl was flame graph, Java was concurrent hash map. We've ported from like spec, right? Which was TCP. But so I feel like just porting a straight C program is going to be pretty funny. Now, it's worth pointing out, and someone pointed this out in chat already, that guff is also the name of a few other tools, some of them related to LLMs, for example. This is not that. This is a tool that just like plots the stuff that comes as input on terminal. And the name is short for MacGuffin. MacGuffin is a term that's used as just like a thing that does stuff. For example, in D&D or in a lot of movies, right? Like there's this plot device that's used, and hence the the dual meaning plot device. A MacGuffin is a plot device that's like a thing that everyone wants because it can do something. And there's no explanation of why it can do it. It's just like, it's a MacGuffin. It's just like a thing that someone came up with that does a thing, right? If you played Baldur's Gate, like the Astral Prism is arguably a MacGuffin. It's a plot device. Like it's not, no one knows exactly how it works, but it's like, it's a thing that lets us carry the story along. And so I really like that naming, but it is also confusing in that it applies as LLM tool as well. But we're not doing the LLM tool, we're doing this thing. In terms of naming it, I think what I'm going to name this is actually dings, which is a Norwegian word that means something similar. Like a dings is like a, it's like a, whatchamacallit? It's a thing. It's a gadget thing. And I feel like a Norwegian word feels appropriate. I was thinking of trying to get an R in there, but I don't think it's that important that it's written in Rust. Thingy is also good. But I still think guff is solid. Thingamajig is also a good name, but it's too long, right? Like if this is a thing I'm gonna run at the end here, I feel like I want it to be shorter. Yeah, I think I might just do cargo new bin dings. We also have the word duppeditt, which is similar. It's like I mean, it means the same thing. It just means a thing that does something, and no one really knows how or why, and that doesn't really matter. Like duppeditt, but that too is too long. I do think that like guff it's so good. Like as a plot device, it's so good. But I don't know that I can come up with something quite so clever on my own. So we're gonna go with dings and then start from there. Dings. Okay. So the basic input thing is here is just a stream of numbers. We're just going to get new line separated input, where the input is going to be, and I think this is dictated down here in the input format. It reads lines of floating point numbers separated by a single character. So here and here, these both read as 1, 2, and 3. If multiple separators appear, then the value is treated as missing for that column's row. Okay, so it's basically CSV, but the separator is space or comma, or whatever is convenient. Any line beginning with slash or hash is ignored, and anything else that str2d considers an ill-formatted number. Interesting. Okay, so it doesn't really do a lot of scanning here. I don't think I'm going to use Ratatouille here. Like, if you look at this doesn't depend on n curses. Like, it doesn't try to build a TUI. And I kind of want to do the same thing. I want to just print a standard item. I don't want it to take over my terminal and do like full screen drawing or anything. I just want it to print a terminal. It also has this nice mode where you can pass in -s to render to SVG instead. And the nice thing is you end up with this binary that just like has no dependencies. It's super easy to run. And then the other feature that it has, I wonder what it does actually if it has multiple column values. Blank lines make guff plot and reset to make an infinite stream of SVG plots. Interesting. That's nice. Why write another plotter? Well, just because you don't want graphic stuff. And you just want a quick way to get a data distribution on the command line. I don't know whether we'll do SVG. We'll see. Ooh, it chooses colorblind safe modes. But I wonder, so like if I have multiple lines of numbers, like this presumably is going to be X and Y, right? But what if I have 3 numbers? What does the third number do? Interesting. We shall see. And like the plotting is interesting, right? Because like here, this is like clearly using basically random characters to draw. So I'm really curious when we go into the code, like how this plotting is implemented. So let's see. Let's start out here with, where's just guff? Here we go. Guff.h. Okay, that's just logging and stuff. That's fine. I want... Why is there FNV in here? Why is the Fowler hash in this algorithm? And why is it hard-coded in? Why do you even need the randomness? What is greatest? Oh, greatest is some kind of testing tool. Okay. So a lot of this we won't need because we can just use normal tests. Okay. It's interesting that it has a bunch of like testing utilities in here. Main.c. Let's see what we got. Gruff could be the Rust version of this. That's true. All right. What do we got at main? So it has a config. That's fine. Where does it read from? Then it reads environment variables into there. Handles the arguments. Loops over the stamp. Whatever is the input. So it does not have to be standard in. I guess if we look at the bottom here. But is file the output file or is file the input file? This feels like I may just need to check this out locally and see. So let's go ahead and grab a third terminal and do dev others git clone cd guff make. All right. /guff. I guess I need some input. What do I want as input here? Let's do let's do find all the files in here. For each one run wc-l. Oh, I want exec. Oh, right. wc-l. And then I'm going to grab out just the first one. What? Oh, one index in awk. Okay, so now we have a bunch of numbers. These numbers are the number of lines in each of the files inside of guff itself. So if I now pipe this to guff, what do I get? Well, that makes sense because this data is it's in random order effectively, right? So this is just like if the input only has one value, that's the y value, and the x is just auto incremented. So if we now sort this numerically, now we get a plot that looks like this. And it's a little tall for me, so I think it does like a 50 by 50, 60 by 30, 30 by 60. No, okay. 60 by 20. There we go. Fits on screen. So the range is printed at the top here. So x goes from 0 to 41. Y goes from 0 to 837. Okay, so we see most of them are down here, and then it goes up a little bit. Okay, so this gives us a sense of the distribution, which is nice. Yeah, Zipf law, right? Like this is how surprising that it's log normally distributed. Okay, but what I want to know is what is the file argument? Like if I press dash as the file, it does the same thing. What if I write this to data, and then I do this, and I give data here. Okay, so the first argument is a file argument where if the file is specified, it uses that instead of standard in. And like for most of these tools, if you give dash as the file name, then that means read from standard in. Cool. All right. There is a man page. That's interesting. Guff. I guess I could open guff HTML. That's awful. I don't want to open guff HTML. Oh, I guess actually I have it cloned locally, right? So I could do dev others guff man HTML. Ooh, that's bright. Inspect. Nope. Inspect HTML. No, that's not. Now I forget what the. Oh, filter. Filter invert. Right? Isn't it? Now I've completely forgotten what the trick is. It's really sad. Transform? CSS filter invert colors. Invert, yes. Yes. I thought, but I'm pretty sure it's just, oh, it's invert 180 degrees or invert like this. There we go. Nice. Okay. Guff is a plot device. This is mostly just the same thing that we saw, although it has a bunch of examples, which is handy. It can do it with log scale. Okay, that's handy too. A linear regression line for each column. That's cool. Okay, so if I do -R, that didn't really give me a linear regression line. Maybe S. Oh, S would be the SVG version. Okay. With point counts. -M count. Oh, I see. So then I see. So if you now have duplicates, you would get a sort of a count of how many things were at that location too. Yeah, it's like these kinds of transformations that I think are really useful, where I would want to add things like CDF, for instance. Okay, yeah, so you can log scale particular things. You can flip X and Y. Dot, line, or count. Treat the first column as the X value for the other columns. Otherwise, the row number is used for the X value. Oh, linear regression is SVG only. Okay. Cool. All right. Let's go back to look at this. So it loops over. So this input read is presumably then going to read whatever's configured to be the input as in config here. DS is a data set. That's a bunch of pairs. So that's what it's going to read into. That's fine. This is because C doesn't have RAII. Interesting. So it does actually, it reads all of the points before it tries to draw. Interesting. I guess that makes sense. So it doesn't incrementally draw as it gets data, which makes sense, right? Because if you have a command line tool that's not a TUI, right, it just prints the output. It couldn't incrementally draw anyway, because it, like, once it's drawn this line, it can't go back and change it because this is not a TUI. It just prints the standard out. Input free, new line. Cool. Okay, so draw is going to be the... Well, I guess we could look at the config too just to see what's in there, but I don't think it's going to be anything particularly interesting. This is just argument handling. This we're going to get basically for free through clap. It's an interesting question whether I even want to bring in clap here or whether I want to use something simpler. ASCII.c, so I think this is the ASCII plotter, so we'll look at that a little later. Counter.c is for tracking point counts. So this would be to make sure that for each value, you can say how many of that value there were, right? So this is the -m count mode, where here, none of the values are the same as each other. And so as a result, all of them are 1. But if we tried to do, for example, do I have something that's bigger? Let's grab in like the source code for Alacrity. What? Oh, right. I need a pattern as well. Interesting. Okay. What if I make it a little wider here? I give it a little more space to work with, and 25. This count mode is a little weird, right? Like, what if you have more than 1 digit worth of count? Interesting. Yeah, I don't know if we'll preserve the M count mode, but this is basically the thing that is needed in order to give you the counting. And of course, this is a manual implementation of a hash table because this is C. And so that's why they need F and V. Whereas for us, we can just use a hash table for this. And I think realistically, I'm not sure we're going to want the count mode. I think instead what we do is store this into something like an HDR histogram. And that way we can plot the histogram instead, which I think is way more useful than the count here. Yeah. A shorter width. Yeah, so if I do 30, that's awful. It starts counting in hex. That's... I mean, it makes sense, right? If you're showing a single character, then that's fine. Okay, what if I go 10? What is G? I think it's not hex. I think it's just, it just keeps counting through the alphabet. And if it goes above Z, it just goes to like hash, I guess. I mean, what happens if I go even narrower? No, it just becomes pound if there are too many. And I see G, so like what if I go 10? What if I go 15? There's the O. I don't think, yeah, I think this is like base 36, right? Like 0 through 9, A through Z. And you could be totally right that this is where the these came from. Right? Because this is X from 0 to 720, which means that it repeats, right? And so you would end up with multiple counts for the same point. Yeah, so that is totally where that comes from. That's really funny. I don't know if it's worth preserving. Like, this is a weird mode, right? Where you want to say how many points are here because you don't have the resolution to show multiple points. But like, it's not bad. It's not bad. I don't hate it. Maybe we'll preserve that, right? Like, if you want to draw a bunch of point clouds, but you don't have the resolution for the point clouds, you just put like names, like the count there instead. Braille characters would be good too. I like that. Okay. So in draw, what do we have? First, it draws the calculated bounds. That one's easy, right? You loop over all of the columns of all the rows. You grab the pair at that column, although I'm interested in how they populate pairs. And then it just looks for... It just grabs the min and max. That's funny. It's fuss tested with AFL. We might want to do the same. That's really funny. So the range is max x. Crosses. Oh, crosses x is whether it crosses the x-axis. And crosses y is whether it crosses the y-axis. If it doesn't cross x, interesting. So if it doesn't cross the x-axis, it might cross the y-axis. If the minimum x is greater than 0, and the minimum x minus the range of x times the cross pad. Why? This is where comments in code are useful, people. Then it sets the min to 0, and it sets the range. Oh, I think this is if the value doesn't cross the x-axis, then you set the minimum x to 0, so you always plot with x at 0. And this is so that otherwise you might end up with, like, let's say you have a data point at like, I don't know, 10, 11, and 12. You don't want to end up with a plot that goes from 11 to 12. You want to end up with a plot that goes from 0 to 12, because otherwise it's very hard to tell where those data points actually are. Yeah. And then it does the same thing here for if the x-axis is to the left, then it goes from whatever the smallest value is, like the largest negative value is, to 0. Same thing for y. And then draw the calculated axis positions is just... Okay, so scale point we're going to end up going to. Okay, that's fine. So it draws the... It doesn't really print the bounds here, though, even though it says draw, right? It just computes what the bounds of the plot should be. If the mode is count, then it does the counting by value. So if we don't pass count, but there are duplicates, what does this plot? Oh, I see. Then they're all just pound characters. Okay. Interesting. So why would you ever not want count? I guess it's to avoid the overhead of this, maybe? But like, this feels like it's pretty damn cheap. Option to disable that. What's that here? Oh, option to disable the grounding to 0 if you're plotting years, for instance. Yeah, that's interesting, right? Like, if someone plots something and the x-axis are like the past 10 years, you don't really want to have a graph that starts at 0. Yeah. calloc allocates this many of this size. So it's the same as a malloc of this value times this value, but just expressed better. Okay, and then if the mode is plot ASCII, then it plots with ASCII plot. Otherwise, it uses SVG plot. That seems fine. So it sort of separates out the gathering of the data and the computing of the bounds. Interesting. Okay, so let's then look at the ASCII plotter. So the ASCII plotter, if axis. Oh, right, because I think it said that there was a I thought I saw something to specifically disable the axes, but I don't see it here anywhere. -A. Oh, don't draw axes. I'm just blind is what I am. So if I do -A, I see, then you get it without the axes. So in ASCII C, yeah, if axis, then draw the calculated axes and draw the axes. But how can it draw the axes before it draws the data? Because you can't draw the y-axis or the x-axis independently of the points. So what does this function actually do? Oh, it just calls this function again, which just computes what the axes should be. And scale point just does... Oh, I see. This just scales to, you have a value that's like 700, but you need to scale it to what actual column of the terminal output does it need to be at. So that's what this file does. But so this doesn't actually draw anything. So it's kind of misleadingly named. And draw axes, what does that actually do? Oh, I see what this is doing. What it's doing is actually drawing it in memory. Like it keeps an in-memory representation of the output so that it can draw things in arbitrary order, right? So that it can draw the axes first and then draw the points. And then it just prints that after the fact. Interesting. I wonder why they did that. Huh. Oh yeah, I can update the stream. Let me do that real quick so that people don't get confused. Let's see here. Give me a second. Let's see if I'm even able to do this in this window. YouTube is really unhappy about me doing this. All right, let me do this and I'll be back in a second. Like so. I mean, like so. Okay. Yeah, so it draws it in an in-memory buffer so that it can draw things in an arbitrary order, and that it prints all of that to terminal. Which we should be able to see if we go in here to ASCII. Prints the header, plots the points. Yep, and then it just loops over the PI here, which is the plot info, loops over all the rows and just prints them. I wonder why they did it this way. I guess it's because otherwise you need to pass around this data. Like every line you have to draw, you would have to like have the thing that prints the line know to first print the axes and then print the data, which would get pretty annoying. Yeah. Yeah, not to mention, like I think it's nicer code because you can actually separate these concerns and you know, the memory footprint of this is basically nothing, right? It's like you're drawing U8s. Like you're allocating like what a terminal sized buffer of U8s. Okay, I buy that. So this computes the axes bounds. This draws the actual axes, and drawing the actual axes here is really just about looping down and then looping across, which is fine. It is interesting though here, like why. I see. If you draw the axes, then you draw, when you go down, you draw pipes and you draw plus for every minor tick. And if you draw the x-axis, you do minus and you draw plus for every tick. And if you don't draw the axes, you still put a line there. But why? Like, why does a line still go there? Because it doesn't actually print that line. Huh. And then it puts a plus where the axes meet. Yeah, so... Oh, but we overwrite that plus with a pound. So this is the other reason, right, to separate this drawing from each other, to draw in memory and then print, is because you get to do things like one layer that draws the axes want to put a plus there, but then the data points wants to plot there, and the data point should take preference over the over what goes there. But the it's the dots that really get me here. Like the white space is fine because you're going to draw over it anyway, right? So you're putting an empty character there. But why do the dots go there? Like for every 5, that suggests that you should get like ticks for every 5, but I'm not getting that when I do -A. Interesting. So there might be something special here in the actual printing. No, that's still... Yeah, it still loops over these. Like it loops through the entire up to the height. And when we draw the axes, we loop also all the way to height. So why am I not seeing these? That's interesting. Okay, let's leave that for now. The other thing it draws, so it prints the header. And the header is just the thing that prints like what the scale of the graph is, X and Y. That's fine. Point counts. Point counts. I feel like point counts has got to be this thing, but... But this looks weird, right? Like this is saying 0 is pound, but that should at the very least be 1 is pound, right? Because it's 1 sample per. If I do M count, then it goes away. So that seems just broken, right? Like this is supposed to be, oh, it's for the columns. I see. This is for, here, what if we do... It's a good way to show this. If I just do like 5, no, like this, and then I try to plot. Just to see that I'm not going insane. Wait, why does that even include the file name at all? What comes out of this? Am I confused? I don't think I'm confused. Oh, it's because I'm stupid is why it is. Like this. D90 by 25. Yeah, okay. So column 0 is pounds and column 1 is printed as ats. And so if I now made this, I don't know, like 100 instead, or something that comes up further up. I wonder further up. Oh, the Y goes to 3,000. Okay, so let's do 2,000. There we go. All right. Cool. So now we know what goes here. And if you do M count, then you're giving up the ability to visualize different columns, but you're gaining the ability to see how many points. Okay, that makes a lot more sense. The thing that draws the axes. Oh, I see. This just puts them in there. ASCII plot. Oh, I see. It doesn't even do this if axes is off. That makes a lot of sense. That still doesn't explain to me. Oh, I see. So that's why we don't get anything printed. But then how do I disable draw y-axis without disabling axes altogether? Draw y-axis is dependent on you draw the y-axis Oh, I see. If any of the data points are below 0. So if I did here minus 2000, and I got rid of this thing. If min x is less than 0 and max s is more than 0. Well, for y, right? If min y is smaller than 0, which it is, I set it to minus 2000, and max y is greater than 0, then it should draw the x-axis. Okay. Oh, less than or equal. Oh, I see what's going on. I see what's going on. So if I do, I don't know if I can do this. Plus 50. And then 2000. Like, I think it's trying to show if you're disconnected from the x-axis, like if you're drawing higher up, then it will draw the x-axis different. I think that's what's going on. Interesting. Yeah, so if you're not rooting it, like if you're not drawing 0 along a given axis, then it draws that axis differently. That's what's going on. But how can I make it do that? Because if I try to make it not draw the x-axis, that means that I either need to make the minimum y smaller than 0 or the maximum y, greater than the minimum y greater than 0 or the maximum y smaller than 0. But I did that. Oh, they both need to be further along that line. Yeah, but that's what I have, right? All of these numbers are now above 0 by like a non-trivial amount. I think maybe there's a padding issue here. So like if I move them far enough away, yeah, I see that it's an and. That doesn't change anything, right? It draws it if they're both true. So in order to have it not draw it, I just need to make one of them false. And in this case, my maximum y is greater than 0. My minimum y my minimum y is not less than or equal to 0. They're both greater than, so this should evaluate to false. Right? Am I confused? I mean, I might be, but like, it could be that it only computes over one of the columns, but that feels like it shouldn't matter. Yeah, I think you're right. I think it's like if your data is close enough, but this feels pretty unambiguous, right? Oh, but I see, but it snaps as, yeah, this is the crosspad thing. Yeah, no, you're totally right. That's what the crosspad is doing, is like, how close do you need to be in order to snap to it? 2. So it's if your minimum y is greater than 0, which it is, and your minimum y minus your range of y times 2. Yeah, so it's like, it's not if you're far enough, it's if the range of your data is such that it basically wouldn't be visible otherwise. So if I do like this, there we go, now it snaps away. So because it's not looking at how far you are from x, it's looking at the span, the range of your data in that dimension relative to the minimum value. And so that's what it's using to snap. Okay, and here you now don't get the x-axis, you get dots instead. Okay, cool. And now we see the, yeah, now we see the dots. Yep. Cool. Okay. And then what else do we have here that's potentially confusing? It's the header plot points, right? We need to look at the plot points. Plot points. Oh, and these are the marks it uses in this order for different lines, right? So if you had 4 different columns, the first would be hash, the second would be at, the third would be asterisk, and the fourth would be caret. Cool. And then uppercase letters, because the lowercase letters you can't use because they're counts. Oh, but you can't combine this with counts anyway. So plotting the points is you loop over all the columns, you loop over all the rows, you grab the pair, you scale it to the size of the output canvas. You get the column mark for that column. If you're using counters, yeah, so the mark is just the column mark unless you're using counters, in which case you get the count. If the count is less than 10, then you use the digit. If it is less than 36, then use the letter. Otherwise, use pound. Okay, so we reverse engineered this from the output. We reverse engineered this from the output. I'm happy about that. This is in fact saturating base 36. All right. So the only thing left then is how pairs, which is like the input data here, this thing, how that is populated. And that happens in main? No, in input, right? Because I think in main, it just calls, yeah, input read. So input read is the thing we need. Input read. All right. Init pairs is just allocating. What does it allocate here? Init pairs ds. What does init pairs here do? Allocates 1 C alloc min row ceiling. Why? Okay. And then add pair, I'm guessing basically re-implements a vector or something. Yep, it re-implements a reallocating vector because this is C, so you don't have vectors. Cool. Yeah, so this is how many rows do you have room for in the allocation? And then I'm guessing there's going to be like a 2x here somewhere to like grow it by double. And when you grow it, you have to reallocate and copy all the things over. Oh, man. Okay, let's go back up and let's read this in order. So it inits the pairs, which is just allocating it. And then it just reads from input. That's fine. Sync line is just, I've now read a line, absorb the line. Interesting. Okay. And this is just skipping comments. So sync line is the thing that will actually absorb a new line into the data set. It swaps new lines with null terminators so that they're valid C strings. Sure. Why not? Love C strings. Current X is the row count unless we get told something else. And then it not number head character. Okay, so this is, it looks for whether the line is a comment. If it is, then it just returns. If the first character is not a number, then it just sets it to be an empty value. Otherwise, it keeps moving. It moves by one character. Okay, this is the single column separation that it tries to move by one character, and then if it now doesn't find a number, then it just goes, this value is empty too. So if you did 1 space 2, what you would end up with is 3 columns where the middle value is missing. That's funny. Okay. If isnan v, okay, what's the empty value here? The empty value is not a number. Okay, cool. That's fine. And str to d here is just parsing a string as a number. And this is a C function that will, this is pretty common in C land. So str to d here is going to, it takes a pointer to the start of a string, and it will return this prefix of the string parsed as a number, and in the process will mutate your string pointer to point to after the number. Okay. And if it reaches the end, then we break. Otherwise, well, line offset. I don't think that matters. Okay. And so now, if we're supposed to read the X column and we don't have X, then the value that we read is X. So this is just like, there are 2 modes, right? One is where there's an implicit X, which is the row number. And the other is where the X is the first column value. And so here, for each line that we loop through, has X get set to false. And we set it to true the moment we read the first column value, and we store that as being the X value. And then we allocate a point which has an X and a Y, and then we add a pair. Does this mean it'll miss the first data point? Oh, no, okay. Yeah, this is just for the first column, not the first row. Cool. So that's a point. What this also means, this is also interesting. So as it walks the columns, it will create a point for every X, Y pair. So it reads column 0, and let's say you have X columns on. It reads column 0, and that gives you the X value. Then you read column 1, that gives you a Y value, and then you store the point XY, which is column 0, column 1. And then you walk to column 2, you read its value. Now you have a new pair, which is XZ. So column 0, column 2, and you store that as a pair. Interesting. Okay. And this also means that I wonder how the pairs are stored, because what if you have a gap? Like, what if you have one line that has fewer columns than the others? Then you wouldn't get pairs for the remaining data points. Like for the remaining column values for that row. I guess you would just, that's fine. It just means that that means that pairs is not a vector per column, because it can't be, because it might have missing values. Instead, it is just like for each column index, you keep a set of points XY. Interesting. Okay. If column goes to max columns, why even is there a max columns? Like, why is 255 the maximum number of columns? Is there a reason to have this upper limit? Doesn't feel like it is, right? Maybe it's so that you can like error out or something, although it just breaks reading. Fill remaining columns with empty value. Oh, so it does actually make it complete. Which is interesting because it doesn't really need to, right? Like, I guess it allows you to keep it contiguous in memory. But this feels like it would be broken, right? Like if so imagine that the first row of your input only has 2 columns, X and Y. And the next row has 3 columns, X, Y, Z. Then the first column, you wouldn't run this code for the first column because you've already dealt with its row. So it wouldn't have a pair. So like, why are these empty value points even needed? I feel like you could just not store them because they're empty values, so they don't need to be plotted. Interesting. Like, well, we could test this, right? So if I did, instead of giving this real data, right, I could just give it, like let's do 1, 5, new line, 2, 10, 15. Like, what does that plot as? What's the star for? Oh, it's because I need to pass X. Yeah, so there's a data point here at 5. And with a, no, at X equals 1 with a value of 5. And this is X equals 2, value of 10. And then this is X equals 2, value of 15 with a different data set. But like there's no value for X equals 1 for the second column data set, which makes sense. But it does feel like if I do this now and do 3, 5, like I think what's happening behind the scenes now, it actually adds an empty pair here, or like not actually there, but it adds an empty data set for this collection, this sequence, for X equals 3 with the Y of empty value, but it doesn't do the same for X equals 1, right? Because here it loops over the remaining columns with empty value, but this happens inside of the loop that is for a single line. So, okay, where does DS columns come from? I guess let's find that out. So where does it set DS columns? DS columns here. No. Yeah, that's just an add pairs. Add pairs will just dynamically update it. Okay, so I don't understand why it needs to add these remaining points because I think they're just unused. All right. A mystery to solve later. These are the valid digits in reading a number. That seems fine. And then add pairs, I'm just going to ignore because we can probably do things a little nicer than that. A bunch of this ends up being just because they need to implement a growable vector. In fact, yeah, so this is the check, right? If you're suddenly given a pair for a column that you didn't have, then you allocate a new vector to hold that column's values. In fact, maybe that's, okay, so maybe this is the thing that ends up adding empty. It is, yeah. This ends up looping over all of your previous rows and giving them the extra column. But why? Like, I don't understand why these empty value points are needed given that they're empty. Interesting. We might just skip this and like see if that becomes clearer when we start writing the code. And then it grows rows, which might require reallocating, but is normally just adding to rows and setting the row value. Cool. Okay. I think we have what we need to start. So how about we go in here and open main? So I'm thinking there are a couple of data structures that we're going to need. right? So we're going to want something that's kind of like a canvas. And the canvas is going to hold our output structure, which is really, you could think of it as a vec of, or you could really think of it as an array, right? Where it's like the outer thing is rows and the inner thing is columns, and this is like a U8. Arguably, it could be a character, right? Because we're drawing them to terminal, but I think it's okay with this being a U8. But it can't actually be an array of arrays because columns and rows aren't known at compile time. So you might be tempted to say that it's a vec of U8, but that would imply that so if the outer vec is rows, each of the inner vecs could actually be of different size. So I think instead what we want this to be is just simply a vec U8. And then we can do impl canvas, and then we can do pubfn rows. I think it actually does need to store its dimensions so that it can return these. So rows is going to be a U16, columns is going to be a U16. And cells is going to be a vec U8. And then, yeah, alternatively, right, you can, instead of storing this, you can just store the stride, which is essentially the column count. Like, it's how far do you move in order to get to each row. So that's fine too. We can do stride. I don't know that it's meaningfully better, but so rows gives you back a U size, which is you take in fact, I think I don't want this to be a vec. I think I want it to be a boxed slice because we don't want this to grow or shrink after we first allocate it, which is the difference really between a vec and a box slice. So it's going to be the number of cells divided by self.stride, where there's going to be usize from. And we're going to enforce basically that these evenly divide each other at the beginning, right? So the idea here is that cells is going to be rows times columns, and stride here is the number of columns if we have this be column based. And so this will be rows times columns divided by columns, which gives you rows. And similarly, columns is going to be that, but it is just going to be your stride is the number of columns. Pubfn new returns to self. New here is going to take the dimensions, so it's going to take a rows and a columns, and it's going to return you a canvas, which I guess is just a self, where the stride is the number of columns, and the cells is going to be a vec of space times, in fact, we could memset this, but it's not terribly important. Rows times columns. So that's going to give us a vector, and then we're going to do into box slice to basically make it now impossible to change its size. And I'm going to say that these are both going to be U16s, and I'm going to do usize from on this and usize from on this, because it feels excessive to allow more rows. We could have them both be usize. Is there a difference between usize from and as usize? Yes. So the reason I use usize from here is because so let's do this here. So if I want to create an X that's of usize, and I want to assign it from, say, rows, then there are two ways I can do that. I can either say as usize, or I can do, let me actually keep that one around, as usize, or I can do usize from. The difference between these is nothing. There's no difference between these in terms of behavior. Where it matters though is imagine that I now say use size is maybe a bad example. Let me use actually no, this is fine. Let's say that rows here I change to U128. So if I change this to U128, then this line will still compile, but this one will not. Because this one will say, you're not guaranteed that a U128 fits inside of a U size. It fails. Whereas a U128 cast to a U size will work, and it will just like do whatever casting a big number into a small number does, which is usually like a overflow or wraparound, depending a little bit on the architecture. But this one, your compiler will stop allowing this. And so that's the reason I prefer the U size from, it's sort of a little bit more, it's like defensive programming in a way, right? Why U16 instead of U size? Mostly because it feels unreasonable for this to be a U size, but I guess it's fine. We can have it be a U size. I don't feel that strongly about it. I just feel like we over rely on U size. Like everything doesn't need to be a U size, and I like using specific types. Why not use ND array instead of canvas? So I could use an ND array here, but I would need to take a dependency on the ND array crate, which like I could do, but I would rather not have that dependency given it was like this much code, right? Now the other thing that I can do here is I can impl trying to debate how I want this to be indexed. I think I just am gonna do it by, I could actually do this. I could say pubfn row. I only ever really need to write to this. I never need to read for this. So I'm just going to say row is this. Otherwise, the convention would be to have row and row mute. So if you give me a row, you're going to give me the row index, and I'm going to give you back a... this is where we need to decide how willing we are for these bounds to be wrong. Let's have it be an option for now. So that will return a mutable list of U8s, but it's an option because if the row index you give me is out of bounds, so I'm not going to give you one. And then I'm going to say that the way you get a given row is you do self.cells dot get mute, and get mute here takes a slice index, which means it can take a range. And the range I want to take here is row times stride. 2 row times stride plus 1. Oh, self.stride. Right, so this is, imagine that row is 0. This will be from 0 to, oops, this is wrong. This should be row plus 1 times stride. Glad I caught that now rather than later. So this is 0 times whatever the stride is. Let's say there are 3 columns. So this is 0 times 3. 0 times 3 is 0. So this is starting at 0. And it's until 1 times 3. So until index 3. So I'll give a mutable slice here of 0 to 3, like index 0, 1, 0, 1, and 2. And that is indeed the first row, right? Those are the 3 first values. If I give a row of 1, right, then I will get 1 times the stride, so 3 columns. So I'll get starting from from index 3 into the byte array, which is right after the first 3 values, right? 2, 1 plus 1, so 2 times the stride, which is 3, so 6. So I go from 3 to 6. So that would mean index 3, 4, and 5, which is indeed where the 3 next values are. So this would be how I get a row. I can't easily get a column because the data here is in row format, right? I'm storing 1 row, then 1 row, then 1 row, then 1 row. And so this is where you'll sometimes see like columnar data formats. So columnar data formats do it the other way around. So all of the columns, all the values for column 1 are stored first in the array, and then all the values for column 2, then all the values from column 3, etc., which makes it really easy to get contiguous access to all the values in a given column, but it makes it harder to access them by row. And so here we've chosen a row-wise layout, but you could easily choose a column-wise layout. I think the reason we probably want a row-wise layout here is because when you loop over the rows, actually it probably doesn't matter here because we're going to index by cell anyway. It might matter for how we store the data points, but I don't think it matters for how we store the canvas. I think either would be fine. In fact, you're unlikely to even use this accessor. I think more commonly, if you want a given cell, so row and column, that will give you back mutable reference to a U8. We could here have it be, instead of cell, it's a write to cell. So you give it the value to write there and it returns like a result or something. We'll see how this pans out and what looks nicer. But this one is just going to be row times self.stride plus column. Like so. Oh yeah, row-wise layout will be helpful for printing because we're going to print it row by row. Totally right. All right, so we have these. Yeah, they probably don't need to be pub here because we're not going to have this be a library anyway. Okay, so we have our canvas, which we can create and allocate at a different size. We can write to particular cells. So that's obviously something we're going to need. The other thing we're going to need is a way to store our data points. We have a couple of different ways that we could store the data here. One of them would be to simply store a data. Might not need a struct, we'll see. So here we're going to need, we're going to have like data sets, and every data set, and the data sets are going to be a hash map from a column index to a B-tree map of, or B-tree. It's an interesting question whether this should be a. We have some interesting options here, actually, for what we want to do. I think this is going to be from X and Y to count. But that feels dissatisfying too. Plus F64 is not ORed, so that's not going to work. But it does feel like we probably want to split these by the columns. Although, and this is where the original code had an idea, right? Which is you might not need to do this because you could say that your X values are just a vector of F64s. And then your Ys are a vec of vec F64s. Right, where this is really a two-dimensional array, where the outer thing is indexed by which Y value column, and the inner thing is all of the values for that column. And that way you don't need to do any of the hashing or anything. The hashing you only really need to do if you want to start keeping track of counts instead. Yeah, it's a good question here how we actually want to arrange this data. Because there's a third way, which is we store point. And every point has an X, and then it has Ys. And then we store, the data is just points, and it's a vec of point. So we do it this way. This one is pretty nice. We could even say that these are stored in order. The awkward thing about it is that we end up allocating, like imagine you have like 100 data points, each with just one value for the y column. Then you end up allocating 101 vectors, right? Because you have a vector for every point, which feels excessive, right? So I think actually this is where the original did have a pretty good, like if you really want to optimize this, and I'm not convinced the optimization matters, but like if you really want this to be fast when you have like lots of input data points, there's a decent argument here that the thing you should do is just keep a columnar data format, where we keep a vector of x's, and then we keep and actually, yeah, and then we keep y's is a option vec f64 of length max columns. Although at that point, like this one, I think it's fine to have the outer vec and the inner vec, because you'll just here have the number of things in the outer one is just a number of columns, and then you have a vector per column, which doesn't seem that bad. And then the other way to do it is that instead of storing the raw data here, we store the data basically in the canvas, or like in canvas coordinates. So you basically store, like, instead of this, you store cells, which is a box slice of F64. But this doesn't work because so the cells here would be like for every actual rendering block, this is the value that goes in that block. But that doesn't really work if you have multiple data sets, because what you're writing in there is not a value. I suppose there's an argument here that you could just not store the data at all and just plot directly into the canvas, like as you read the data. But you can't. You might redraw the same cell multiple times, because if you're using something like count, the value in there is going to change over time, and it's going to get hard to layer them, right? Because imagine that you have column X and column Y, and column Y and column Z. It's just whichever one you draw last is going to be the one on top, because you're drawing directly into the canvas. You're sort of, there's no separate place you can store the data and then decide what order to layer them in. Yeah, I think we're just going to go with this one. So we're just going to store the X values, and we're going to store the Y's in columnar format, which does end up in the same thing actually that the original code had, which is if you discover that there's a new column, you have to go back and add some value for that column for all previous rows. Which I think is probably okay. Okay, let's do that. So I'm fine with that being the data. There's an interesting thing here too, where we might want to pre-process the data, right? Counts is a good example of this. But if we wanted to go do something like a CDF, then the way that you do a CDF is you would take all the input data, read it into a histogram, and then walk over the histogram and produce a new data from the previous data. You might even be able to stream the data into the histogram first. There's a crate called ordered float that lets you declare like not nan of F64. But I don't think we need it here because I think we can do the same thing as the original thing does, which is not a numbers don't get printed. Like the empty value is not a number, which I think is fine here. Yeah, I think that's fine. Let's try this and see how it pans out. It also, yeah, I like that it's similar to the original. It lets us sort of translate concepts between that better. Let's start writing the sort of relatively straightforward parser. I'm going to wait with argument parsing for now. So for now, we're just going to say std_in is io std_in .lock. And I think actually I need to do this, right? And then because I want to lock it so I don't have to relock it every time I read something. And then while let some line is std_in dot what? Oh, read line. Give me buff read, please. Line is string new. I think it's fine to require them to be valid lines. We don't care about that, so we can just do while this dot is sum, read line, and read it into line. Oh, is okay. Oh, that's not what I want. Yeah, while let, we do actually need the, so we need to know when to stop. So really what this is going to be, it's going to be a loop where we're going to do, let n is this question mark. And then if n is 0, which is the end of the file, then we break. And at the end here, we're going to go with an OK, which means here we're going to need a result. This is where we need to start making decisions about how many dependencies we want to take. Because here it's tempting to bring in something like miet or something like air or like anyhow. Or we could just not do that and use like IO errors. I dislike IO errors because they don't let you give context, but at the same time, I don't think there's going to be all that much context in this program. I think we're just going to stick with IO errors here for now. I'm okay with that. So there is a std_in.lines. Although I don't think, that's a good question actually. What does lines here do? Because I think lines will, yeah, every time you read something from lines, it allocates a new string. And I wanted to not do that. But that's mostly in my striving for ultimate performance, you know? So we're going to do this, then we're going to do line dot, yeah, so there's an interesting question here about what we care about trailing new lines and stuff. I don't think we do, but we can do line dot trim end. Okay, And then next is the question of whether we want to preserve the behavior in the original code of, do we want to preserve the original code where it will treat any single character as a column break? It's a little weird, right? Like the original code is basically, it ends up being something like, num is line dot characters dot actually no, it's line dot find next non num. I'm trying to write what the original is. And the original would be not c dot is ASCII digit, or and c not equal to, we could really do actually, I suppose we could do a match here, right? So we match on C, and 0 to 9 is not what we're looking for. Actually, we can just do this, which is going to allow us to simplify it further. So if we get a 0 to 9, a minus, a plus, or a dot, matches macro. So we're going to find the first thing that doesn't match any of these things. That will be the index of the next thing that is not a number. And then we're going to dot unwrap or line.len. And then next num is going to be the line until the next not num. And then the line is going to be line from next not num and onwards. Right? So we're pulling out the characters, a substring, until we hit something that's not a number. And if we don't find anything, we go to the end of the string, or like the next number extends to the end of the string. The next number is then what comes to there. And the line that we're going to continue to process afterwards is whatever comes from that character to the next. And then crucially, the bit that really happens here is like, in the original, this is basically a +1, right? We skip exactly one character. And that feels weird. Oh yeah, this can be split once, right? Which takes a pattern as well. So split once at the first thing. Yeah, but this gets rid of the character that gets split, which I guess is exactly the thing. Although split once fails if the string is if the delimiter does not appear in the string. So I guess that means it would have to unwrap or unwrap or line and nothing, right? So this would be next num, and this would be remainder, and line would be remainder. But I agree, that's nicer. And then v here is going to be next num dot parse as f64. And we're going to match on that. And if it's okay, then that's our v. And if it's not okay, what does the original do here? Like if it reads something that is not a valid number, if is_inf, which I guess is what it returns if that's not a valid number. So if that's an error, then it just silently skips the value. Cool. So which I guess, like, there's like a to-do here, right? To-do print e, which I'm gonna not do right now, but it does feel like this is where we might want to add a logging thing of some kind. Yeah, we're gonna split this out of the main function. Don't worry about it. Like this is just I'm building up the structure of the program until I get a sense for which parts to split out. Okay, so that's our V. And then the line is going to be the remainder. And this is then going to be while the line is not empty, we're going to do this. When we eventually break, so each one of these is going to give us a V. And I mean, this ends up mirroring quite closely the code in the original, right? Which is, there's like a, for each line, we're going to keep track of X, the X value. And this actually is going to be for row in 0. It's an interesting question of whether the first value, if we don't have the X's be in the input data, should the first row be X equals 0 or X equals 1? That's what we're basically deciding here, right? But this is going to be let X infer X, or X is row is false. So X is row, then I think there's a then sum. Yeah, then sum row. Right, so this is if the X is the row, then we set X to be just sum of the row. So as in we've already read X. Otherwise, the X is none, meaning we haven't read X yet. So here, if X dot is none, actually this is going to be if let sum X is X, else X is sum of V. And I suppose this is going to have to be as F64. Right? So if we already have an X, then now we have a data point. Otherwise, we found X value. Now, the other thing that's interesting is we don't currently have the column, right? So the column here is going to be let mute column is 0. And down here, column plus equals 1. If we find the X does not count as a column, right? So if we think the columns as being output columns here, so the first output column is the second value if X's are in the data, if X's are the rows. Okay, cool. So at this point, we have a data point. And so now if we say up here, let mute data is data new, or data default, which we don't currently have. But this feels like a derive, debug, and default kind of case. Probably same for canvas, should be debug at least. Data default. And so now, if I do, I guess we can have a convenient accessor here too, right? So let's mirror the original here. So it's gonna have an X, which is an F64, a column, which is a U size, and a V, which is an F64. So this is saying set the value at X, set the value for column at X this to be this value. And we could have like, there's a point type, right? That they have that's just like X and Y. But I think this is okay for now. So adding a pair is then going to say self.x.push x. And then the next thing we're going to have to do is we're going to do self.ys. And we almost kind of want like an entry API. We want entry number column. And if it doesn't exist, we have to create all the ones in between. And I think the way we're going to do this is for C in mute self.ys. No, here's what we're going to do. For C in, what I want to do is, right, I want to have a way to construct the vectors for any missing columns. So I think what that's going to look like is if the column is greater than ys.len, and I think there's an off by one error here, because if so column 0 if we want to insert column 0, then 0 needs to be greater than 1, which doesn't work. So there's an off by 1 here, right? So that we also make sure we have the current one. And then, but regardless, I'll fix that in a second. Then we're going to loop over the difference between the two. So self.ys.len to column. And each of these, so these are all the additional columns we need to add in order to get to this column. And I think actually we know there's only ever one, because we like the code that calls this knows that it calls the columns in order, right, for any given row. So we know we will only ever extend by at most one column. So we could, in theory, simplify this, but I think this is fine, this for loop, because it's a trivial to allow it to skip by multiple columns. So for C in the difference here, need a new, discovered a new column. Need to add it for all, need to add the column, which means adding empty values for that column for all pre-existing rows. So this is then going to look like the new column is going to be a vec of f64 nans of length self.x.len. Right, so we're creating a new column that is going to be nans for all of the rows, including this one. So we've already pushed our x, right? So including this one. And then actually, maybe I don't want to include this one. Let's do without this one for now. So it'll be nan for all of them up to, but not including this one. This is where it gets weird that it can extend by more than one. I think we're actually going to assert. I think we're going to assert that you only ever add at most column, at most one column. So if the column is greater than the length minus 1, right? So this would mean that there's no, that index is not valid, on wise.len, then assert equal column self.wise.len. So this is basically assert that the column we're adding is only one past the number of columns we already have. Add pair will only ever add a single new column at a time. And so that way we know here that there's only one, and we know that we're about to add a value for it. So therefore we can say it actually doesn't matter whether we do this or not. I think we're going to do it with the updated length so that we don't get an accidental resize by when we push one value, right? So we're going to push here our new value. In fact, we can do that outside the loop. So we're now going to say self.wise.push new C, and then this is going to do self.wise column push V. Like so. Yeah, that's pretty good. That's pretty good. And so now down here, if we have a data point, we'll do data.addPair of X, and the column is column, and the Y value is the V that we just read. Cool. And then at the end here, we'll do a debug of data. Excellent. So if I now go back to the data set that I had, yeah, sure. Why not have multiple columns? That seems fine. So if I now go here, and we do this in here to cargo run. Tempted to subtract with overflow. Oh, I guess, yes. Because if this is already 0, then subtracting from it would fail. It's fine. Whoa. Does that make sense that we got this much output? This feels like too much output. We're getting a bunch of 5s. And this feels like something's wrong, right? Let's maybe try with something easier first. So let's go back here, and then we do echo-e 1 5 2 10. Well, that's clearly wrong already. That's clearly wrong. So first of all, there are only 2 rows, and yet we ended up with 4 X's. Let's go ahead here and do debug of X and V. X is none, V is 1. And then X is 1, V is 5.0, right? So this is what we expect to happen. So we first don't have an X, and then we get a V that we decide is the X. So on the next column value, we set X to be sum of 1.0, which is the V we got in the previous row, and V to be 5.0. And so now we have X and V, which should be a data point that we add. And then for the next line, X is now none again. Why? This feels something's fishy. line 1, 5, line 1. Oh, I've made this mistake before. When you call read line, it doesn't clear line for you. You have to do it yourself. So line.clear, otherwise it just appends to the string. So now, great. That's much more reasonable. So now the line is first 1, 5 new line, then it's 2, 10 new line. And our data ends up with X being 1, 0, 2, 0. Our Y having one entry in it, right? Because there's only one column. And the values for those is off by 1, right? There should only be 2 values in here, which is because it's almost certainly because of this extension here. Oh yeah, didn't I make this -1? Apparently not. Great. Cool. So now we have data collection. You think I had X twice? Okay, try. Okay, so now we can try 1, 550, 2, 10, 100. Oh yeah, we do end up adding to X twice because we add it for every Y value, which isn't right. So it's really almost like interesting. Yeah, no, you're right. Where this breaks, right, is that we are adding we're adding a data pair every time we encounter a column value, but we also then add to the X every time we do that, which ends up being wrong. Instead, I think we need to add to X every time we get to X, right? And here, we're not really adding a pair, right? We're just add column value, which sort of breaks the abstraction a little bit, right? Because it's really just add column value. This sort of assumes that you've already pushed the X. There's a lot of assumption built into this. Yeah. They have add pair. How did they not duplicate? It's a good question. Let's go look. So I think it's because inverse column equals column inverse. And DS rows. Grow rows. This is the power of 2 growing, but assuming we don't have to add a column, we don't have to grow. Pairs, column and row. Interesting. They actually just keep a single vector. They just keep the whole matrix. which gets awkward because you don't know the number of columns or rows in advance. And so that's why this ends up kind of complicated, because you need to walk the old stride. No, I think they do actually have they do have nested allocations, because this is an allocation for just the column pointer. So they do have a vec of vectors. But I think it's because they don't store the x values separately. They actually end up repeating the x value lots of times. They store the x, so P here is a point, and a point includes x and y. And so they store the x and y values together separately for every column row combination. Whereas we're trying to store the x values separately from the y values so that you don't end up duplicating them. I don't want this to be a B-tree map, because you could legitimately have multiple data points with the same x but different y. So we can't assume that the x uniquely identifies the data point. And like, actually, we have a... So there's a bunch of people suggesting in chat here that we could just store like the x and a vector of y values, but we don't want to do that, because then we end up allocating a vector for every point, because we don't know the number of columns in advance, right? The number of columns we discover. And so that's why we're using a columnar format here. And the only awkward part is when you discover there's a new column, you need to change things. I think actually we can do this quite nicely in a way that we don't really need the data struct here. I think we can just have these be this. This is like configuration, that's data. And so we can say here that we push to x's. And at that point, we actually don't need to keep the x around, although we can, because we need to keep something around to track that we've gotten the x, so we shouldn't treat the next value we read as an x value. And then here is where this code goes. And again, this is not all going to be in main. We're going to move it around. So if we get a value at a column that we've already gotten the x for, then we potentially extend y's by one column if we need to. And that column will be of length the number of x values minus one because we've already pushed our own x value onto there. And then we push our value onto that column, and then we increment a column. So this, I think, will be right. We can't keep a hash set of x and y pairs either, because you could have multiple instances of the same xy value, and those should still be treated as separate data points for the purposes of something like count. It could be a hash map from xy to counts, but at that point we're just doing a bunch of hashing that we didn't really need to do in the first place. A columnar data format is the right thing to do here. It's just a little awkward in setting up the data structure when you discover columns is all. So this, I think we will only ever add a single new column at a time. The one thing that we do miss here is, imagine that you now get a row that has too few columns. So that would be down here. Make sure we fill in the other column values. So this is going to be for y in mute y's. if y dot len is less than x's dot len, then first of all, we can assert equal that y dot len is x's dot len minus 1, right? It should be that we've only failed to add one value. And then we do y dot push f64 nan. So now we're walking all of the columns, and we're making sure to add values for any of the columns that we know exist but that we didn't see. You can't pre-allocate the right number of columns because we don't know in advance how many columns there are going to be. Why fill other columns with nan as opposed to using get xy unwrap or nan? So I think the proposal is that instead of using nan here, we could have these be option f64. But option f64 is just larger without giving us a benefit, I think. And nan is sort of the right value for the f64s here, right? Because it is not a number. Like, we don't have a value for it. And I don't think option f64 gives you a niche so that it gets optimized. Yeah, I don't think it does. Doesn't mean that we could end up with like infinity here, for example, if we parse out infinity. I wasn't saying to do the pre-allocation right away, but to ingest the data in the most natural format for that, then transform it to columnar. It's not clear that there is a natural format. Like the natural format, right, is a vector of vectors. But then you end up with allocating a vector for every point, not even for every point, for every line. And that's just excessive. If we were willing to do that, we could have just done that from the start. And so if we're not willing to do that, then we just need to do the thing to maintain the columnar format, which like is really not that bad, right? Like, to do it this way. And so now I think we should be able to do x's and y's. And if I now run this, great. We now have the x's are 1 and 0. The y's are 5, 10, and 50, 500 for the two columns. There's an interesting question here about like if we want to sort the input data, for example. But I'm not too concerned about that. The nice thing now is we can now loop over the data pretty easily, right? So I can do, what would be the nicest way to do this, right? So I do for row and x in x's dot iter dot enumerate. And in fact, I can do copied because these are numbers. And then for column and y in fact, I don't need to do that. I can just do for column in 0 to y's dot len. Those are the number of columns. And the cell value, which is the y value, is y's indexed by column, which I suppose I could do y's in y's. Except I probably do want the column number. That might be useful, unclear. But y's dot iter dot copy, no, dot iter dot enumerate. So y is going to be y's of row. Right, so with this, I should be able to now print out like all of the XY pairs that are in here, right? Just as a sort of sanity check, this prints out 1, 5, 1, 50, 2, 10, 2, 100, which are indeed all the data points. Test with 1, 2, 3, 4, 5. Sure, let's do this. Yeah, so now one for this row 1 for the second column is not a number. And crucially, we can also do 350. And so the y value here, like the array is, or the set of arrays is still consistent here, right? Because there are as many entries in each y's as there are in x. There are definitely some things that are kind of awkward here, right? Like this, for example, will still now only consider a single character difference. And so here, if we fail to parse whatever is the next value, then we treat that value as being not a number. And then we just walk right on past it. But do we skip the character? Because there's an interesting question here, right? Like in the original, there was this setup where, like, let's add another column here, right? So let's say we have 1, 2, 2, 2. Then I should be allowed to do 4 space 4, right? Like single delimiter, nan should be the middle value. And indeed, that is how we parse it right now. And I'm pretty sure, I mean, this is a thing worth checking, but I'm pretty sure that if we gave this here to guff, right, that I think it would plot the way we expect it to, which is that the first column should have 2 data points, one at 2 and one at 4. The second column, so star, should only have a single data point at 1 at 4, which it does. And there are no... Oh, that's a caret too. No, asterisk, I mean. This is because they're all the same value. So let's do 3, 4, and then at 2, we'll do the same thing. So pound, which is the first column, should have values at 2 for both data points. So it has one there, but there's no pound here. Why is there no pound here? Star, which is the next column. Oh, it's because I haven't passed dash x. Good. Okay. So this is x1 and x2. For the first column, we get a value here, 2, right? Which is this 2. And here 2, which is this 2. The second series is ampersands. Ampersand has a value here, does not have a value here, which is the empty value. And star is star here and star here. Now, the thing I wanted to test is what happens if I had an extra space here. I get the same behavior. What if I had another space here? Then... Interesting. Yeah, okay, good. So with the extra one, it thinks there's another data column now, which is, it thinks that there are now 4 columns. This one, or I guess let me move up here maybe, right? So it thinks that there are 4 columns. This is column 1. This is column 2. This is column 3. It's a little unclear how this splitting is reasonable. Splits by single character. So this would be data set 2. This would be data set 3. And then this would be data set 4. This single character splitting is inconsistent at best. Right? Like, if it truly required single character delimiter, I would expect to see a delimiter there, a delimiter there, and a delimiter there in order to get to 4 data points, or four sequences rather, 4 columns. I think this might be just a bug in the original guff, but it's also something that probably no one makes use of, that like an empty value is nothing. Well, I guess 1, 2, 3, 4 delimiters, which should imply 5 values, but they're not 5 sequences, so it's not really single delimiter either. Every 2 spaces. It's not every 2 spaces either, because, well, that would be 1, this would be 2, and then this would be 3, but there are 4. It counts the gaps between the delimiters. Yeah, but I can't make that. I mean, let's make it be commas, right? So this produces the same behavior. But it claims here now that there are 4 columns, 0, 1, 2, and 3. And yet 0, like 1, 2, 3, 4. No, 1, 2, 3, 4, 5, right? And then I just remove the spaces in there. So there should be 5 columns, but it finds 4. And I think it's because there's an error in the parsing here. I think something eats a delimiter or like fails to continue or something, because my guess is if I do this, then I get 5. So it just gets confused if there are 2 delimiters in a row and it can't parse the value. But that's awkward for us, right? Because it means that our thing will actually parse things differently than they will. But I think ours is more reasonable? Question mark? Right? Like if we did the same thing here and we said, so now we claim that there are 4 columns with this. So let's do 1, 2, 3. Right, so 1, 2, 3, 4. So right now there should be 4 columns, and there are. And if I add spaces in here, then we now treat the spaces also as delimiters. And so therefore there is 1 column, 2 column, 3 column, 4 column, 5 column, 6 columns. 1, 2, 3, 4, 5, 6. Yes. So our parsing is consistent with the logic that every non-numeric character is a delimiter. But I'm going to claim that this is not, because then there should be 6 columns here. So in other words, there's an inconsistency here in, like, guff claims that every single character is a delimiter, but it doesn't enforce that. I think this is fine for now. I think we're just going to leave it the way it is for now. We could always choose to change this to be like split Y space, so it like split by runs or something, but I think for now we're good. We don't actually care about this X that we've stored. So we can just do if X is sum. This error we still ignore. I'll leave a comment here too that invalid values are treated as NA, as missing. Cool. All right, so we now have, I'm going to call it sensible data input output, right? And so now the next bit is going to be plotting this data. But first we're going to have to compute some metrics over it, right? So we're going to need x min and x max, which are going to be, I don't think there's a function currently that takes an iterator and gives you the min and the max separately, but I think we're fine here to just do x's dot, is there just a max directly on it? No, okay. Well, max x and min x. So this is going to be min, this is going to be max. Min y and max y is going to be y's dot iter dot flatten dot min, and max here is going to be max here. Oh, but I can't compare them because F64s aren't ORed. Min by this takes an A and a B, and we're going to do A dot total comp B. So total comp is the implementation in the standard library of basically of ORed for F64, but through a function. The only thing we need to be careful here is we want nans to not end up at the min or the max. So yeah, the problem here is our min would always end up being nan. And so I think what we're going to have to do here is filter F64 is normal, neither 0, infinite, subnormal, or nan. Well, but I'm okay with zeros. I think I actually have to do v is nan. So I want to skip the nans. And this is where it would be a little nice to have them be options. Oops, I put that in the wrong place. Cool. We shouldn't have infinity values. Although, like, in theory, I guess someone could write INF, but if they wrote inf, it wouldn't match this. And so you would never get to a point where parse is parsing out infinity. But we can do that here, right? We could do if v dot is infinite, then F64 nan as well. But like that feels overly, I think we can just do assert infinite. So now is finite. Does is finite do that? Is finite is neither infinite nor nan. Oh, you're right. Great. Let's use that instead then. So this one, we're gonna make F64 is finite. Nice. That does look way better. What? That's okay, fine. I'll take them copied. I don't care. Here and here. What? Why? It's an iter over F64s. Oh, it's because yeah, I mean I can keep the copied actually anyway, but it is because is finite expects to consume the its argument, but what you get in filter is a reference to the argument, so we still need the closure is finite. but that's fine. It's not the end of the world. Okay. And let's do a print line here, just a sanity check. So X is in min X to max X. And Y is in min Y to max Y. Oop. Right, these may be options because we may have empty data. Although, in fact, we could have only X values and all the Y's are nans. That's funny. Yeah, so all of these could be none. Cool. So we now know the range of X here is from 1 to 2. The range of Y is from 2 to 4. And so we can stress test this little, right? Where this column is 5 and then like this column is 20 and it should get from 2 to 20. Perfect. I suppose we don't also need to count these after the fact. We could actually keep track of these as we were running. But it feels more right to compute them after the fact. It does feel a little wasteful to compute min by and max by separately for each one. But such is life. Okay, so now we have the X and Y. And so now we need dimensions to scale these. So width is going to be 90. Height is going to be 25. And so now we're going to have to scale each of these. So scale is going to be I guess this is where we need the code for figuring out what range we're actually plotting. So not just the range of the data, but what range we're actually plotting. So this is the code that was over in, not in input, but over in draw. I think it was in draw. Yeah, for calculating the bounds. This is basically where they're computing the min and max X and Y. Yeah, there's like an interesting thing here on if we want to log transform the data and stuff. But that I think we can treat separately. Scale get transform is just if you want to scale the data to be log X or log Y. What is scale transform here? Is I see. This is just how to transform it into log X and log Y, because you need to do that for the min and the max as well. That's fine. We're going to ignore scaling for now. And then we basically want this exact code, right? This is the point at which, or maybe actually a little bit ago, is when we now need to look at the license of the underlying code and make sure that we license our thing the same as their thing. I think their ISC license, so it should be okay. It's worth pointing out. This is a clamp. So this is if, I see, if it's not quite a clamp. If min X is equal to max X. Actually, no, it is. It's let min X is, no, max X is it is the max of min x plus 1.0 and max x. Right? So the max x needs to be at least as big as this. Oh man, all of these errors. I really need to figure out how to get rid of these again. Yeah, and similarly max y is going to be at least min y plus 1 or itself. Cool. Range x is max x minus min x. And similarly, y. Crosses x is if min x is less than or equal to 0 and max x is greater than or equal to 0. And crosses y is same for y. Why is crosspad assigned to a variable here? That seems weird. F64, and we saw this was equal to 2. If not, crosses x. And this is where my code is going to have comments to explain what's going on here. So if min x is greater than 0 and min x minus range x times crosspad is less than 0. I realize I'm swapping the arguments around compared to how they had it, but I find this easier to read. Else, if max x is less than 0 and max x plus range x times crosspad is greater than 0. Okay, let's make this a comment so that I get formatting and the like. There we go. Oh yeah, what do they do if there are no values here? Min p is max. They just have a predefined max value. Cool. They just clamp minimax to this value. Why? So this means that if I gave gruff dash x and I said 1 space 2 space, it plots nothing. Why does it plot nothing? I see, because something exits earlier if there are no column values or some such, right? I'm basically trying to see if I can trick it into actually using those bounds, or whether that's checked. Oh, it's here, right? All empty points. Yeah, it's definitely this. Yeah, if min x is max or if min y is max, then it just exits. All right, that's fine. So then what we'll do is let, in fact, we can do this. Let's sum min x, sum max x is equal to min x max x, else return OK. There's nothing to plot. And we can do the same here for min y and max y. We also know that if min is set, then max is set, right? Because they're operating over the same data. Cool. And now this can go away, and this can go away, and this can go away, and this can go away. Now, oh, the fucking total comparison again. F64 is why you like this. Why are you like this? Okay. So we'll do max by, and then here, can I just do F64 total comp, or do I need to make it a closure? Ooh, because then I think I can do the same thing here. F64 total comp, and it looks a little nicer. Max by. Yeah, that looks nicer. Okay, great. Cool. Maybe a new type for F64 ORed. They're not ORed. Like F64 just isn't really ORed. This is what the ordered float crate is for. It gives you that type. It gives you it in the form of like a not nan wrapper, which allows it to be ORed. But I don't think we actually need such a wrapper. I would rather do this. And again, the trick here is to skip things that are not finite here, right? So that means that now the definition of total comp is way more reasonable because there are no nans, there are no infinity. And so it's just negative numbers, negative subnormals, -0, +0, and then normal numbers. So it ends up being normal ordering because we excluded anything that's not finite. Okay, so we're down here. Right, so if we're in this world, then min x is going to be, I suppose these actually do need to be mutable, which is kind of interesting, right? So min x here is going to be 0, and range x here is going to be max x. And I think it's the same thing here, except min x is going to be, oh, it actually, I guess max has to be, where are my mappings here? Mute. So here, this is going to be max x goes to 0, and range is going to be negative min x. What? Didn't I make that mutable? Oh, right. I need to make it mutable here as well, which means the max values don't need to be mutable here. Cool. And similarly, if not crosses y, and I think the crosses y code is exactly synonymous, just using y instead of x. Yeah. So arguably we could have a little helper for this, right? Instead of having this be reliant on me getting all of the x's and not missing any, because I definitely will. Y. Okay, great. So this is now, so this code is if along a given axis we don't intersect, the data doesn't intersect the axis itself, we'd like to start / end plotting at the axis. This makes data sets read slightly more reasonably, since they'll start at 0 rather than starting at some other value that just happens to be the minimum of the distribution. However, if the data is sufficiently far from 0 and sufficiently narrow and has a sufficiently small range, plotting from 0 would squish it so much that it won't be readable. And so we try to find a heuristic in between that generally results in reasonable display behavior. Oh, there's an F64 min-max. Is there? F64 max. Oh, yeah. Cool. That's better, I agree. Nice. That's fine. These values are never read because I'm about to start reading them. Cool. So down here now we have the actual range of X. So, and we also now have the size of the terminal. We plotted that up here. And so the next thing now that we need to do is scale every value to the range that we're plotting. And we need to scale that to the terminal, right? So there's sort of two levels of scaling, right? So we want, the way to do this is you take the value and you find its percentage in the x-axis and the y-axis, like percentage of the range. And then you multiply that by so let's say it shows you it's supposed to be at, 50% of the x-axis that you display. And then you just take 50% of the width that you have, and that's where the point goes. So this one's actually pretty easy. The interesting question is like how we're gonna do this in terms of points to plot. I think this is where we create a canvas. Did I already create a canvas up here somewhere? I did not. Okay, cool. I'll create it here. Canvas is canvas default. So now we're going to walk all of the values. We are going to, as fraction of axis, and we'll do the same thing for x actually. X as fraction of axis is x divided x minus min x divided by range x. And similarly, y as fraction of axis is y minus min y divided by range y. Let's double check that that code actually appears here somewhere. It ought to. Draw axis position, count points. That computes the axes. Oh, I need to go into ASCII. ASCII.c. Print points. Print points. Where are you? Here. So you scale it to be log x log y if necessary, and then scale point, which comes from here, And scale point does what? It does a scale transform, which is the log part, which we can ignore. Then it gets the x and y. And x is going to be... Interesting. What's the padding for here? Assert that x is greater than min x minus pad. Oh, so this is just an assertion that we basically did the scaling, right? And then you have a little bit of a factor to allow that the scaling might mean that an x point like fell slightly outside the axis because of rounding or something. Interesting. And then you take the... Oh, I see. They do it the other way around. So they compute how wide every cell is, which is the range over x divided by the width. So that's how many like x data value range every cell in the window is. And then you compute your x as being the window minus pad. Yeah, so the window width minus how much you're going to pad it with, multiplied by x minus min x plus the cell width divided by 2. Y plus the cell width divided by 2. But like this is basically the code we wrote, right? It's x minus min x divided by range x multiplied by the width of the window. I'm just curious why they also have this cell width. I think this is rounding. This is to make sure that you don't want to crop. So without this, I think you always end up choosing the cell to the left of the data point. So imagine that a data point is at like the very end of one cell of your terminal. I think this will end up then putting it in the next cell instead. Yeah. Okay. Flip Y at the bottom of the plot. I mean, we can just grab this and see it in the editor because it'll be nicer. So let cell width is range x divided by width as f64, and the cell height is range y divided by the height as f64, which we can compute outside the loop, which is nice. And then we compute x's fraction of the axis, and here the note, the addition of cell width divided by 2 samples the center of the cell instead of its left border, left edge, plus cell width divided by 2. And similarly here, this will be this plus divided by 2. The plus here and below Yeah, I mean, it's basically rounding. Okay. And then there's also this padding, which is that we don't actually want... Yeah, so this is y as a fraction of the axis, right? And then what we actually want is the like plot width, which is the width minus some padding, where let's say pad is 1. Is this in cells? Do you think the padding is in cells? It's got to be, because W is in cells. Okay, so let's say pad is 1. So plot width, plot height. But then shouldn't it be pad times 2? Assuming you want to pad on both sides? I guess not. So X cell is now going to X cell is going to be the plot width. I suppose we can do times X as fraction of axis, and Y cell is plot height times Y as fraction of axis. The only thing that's tricky here is we're going to treat this as an integer, right? So we're going to do this is where I'm like, I don't know that the cell width matters here, because I think we can just round here instead. Right? Because this ends up I think we can compute the fraction accurately and then just here round when we turn it back into an integer, right? Because alternative, so the thing we now end up doing is just this is just casting this to an integer. But I feel like it's just as good to just compute that entirely in F64 and then just round when we do the computation here. So that this becomes as F64, this becomes as F64. And then this, we now do this dot round. I wish there was an integer round, but I don't think there is. Actually, what happens when you do a cast F64? I thought it truncated, but maybe it doesn't. F64. I'm hoping this is at least documented here. Yeah, it rounds towards 0. But so is there a round and round to the nearest integer? I'm pretty sure there... I guess that's what this does, right? Is it ends up so that when you cast it to an integer, you know that you have... you know that truncating will give you the right result. Yeah, I think that's where they're coming from, but I want to say that round as usize does the same thing. That if you round up to an integer, right, rounds to an integer, and then you cast to usize, then that will presumably give you the integer you just rounded to, right? Like if 0.6 rounds to 1 and you cast it to usize, I'd be very surprised if it returned you 0. At which point if that is the behavior, then I don't think we need this. So I think maybe they did this because they didn't have round. Yeah, I'm just going to get rid of those. And then I'm going to say that this, oops, yeah. And then I'm going to say that this dot round as usize. Cool. And then there's this bit, flip y, 0 is at the bottom of the plot. Yeah, so this is y as a fraction of the axis, gives us the y, but as a positive number counting down from the top, but we actually want to plot from the bottom up. And so this is just y cell from top. Y cell is going to be the height minus y cell from top minus 1. Cool. And so now we should be able to tell our canvas, we should be able to do canvas.cell, x cell and y cell. Actually, I suppose this doesn't work, right? We need to give it a new, where this is going to be the rows is going to be the height, and columns is going to be the width. And so this, we can do let some cell is this, else panic, invalid cell, x cell, y cell for data point x, y. And now we should be able to say that that cell is going to be equal to, let's just make it pound for now. Oh. And it's true, we don't actually use the column. We can see if we can get rid of that later. And so now let's do for row in canvas dot rows. Yeah, we're going to do this. So 0 to that. Let row is canvas dot, I suppose actually this, we could do this a little better, right? So we could say this is n rows and n columns. But then you can also get an iterator over, iterator item is a slice of U8s. Which is then just saying self.cells dot, and this is where we can use chunks exact of self.stride. Right? Because chunks exact iterates over a slice in chunks of exactly a certain size, and we know how wide every row is. It is self.stride, so this will give us exactly an iterator over those. And crucially, chunks exact gives you back, like each item of that is, if we can find the implementation of iterator for it, its item is a slice. So we end up with a bunch of subslices. Why is it unhappy with me? Oh, right, because this now should be able to just be for row in rows, print line. In fact, here we can do stood out is stood out. Let's stood out is stood out dot lock, and then we can do right to stood out. In fact, we can do row. We can do stood out dot write all row. And all we need is here to grab this. And then I can write to row a new line. In fact, I can just write line row. Stood out, I mean. Write a new line to there. And now, it crashed. Invalid cell 4522 for data point 12. 4522. That's because cell takes the row and then the column. So those are reversed. How's that for a plot? Well, I forget what we sent in. 1252. Oh boy, let's make this something more reasonable for now. So we should now have a data point at 1, 2. Yes. And a data point at 2, 4. Yes. Cool. Okay. Okay, we have a plotter, right? And now if we said this is where the column is going to come in. So if we say, in fact, we can grab that from the code over here in ASCII again. Color marks, whatever, const marks. So we'll go up here, put that up here, const column marks, which is going to be a view weights. It's going to be that. And then down here, we do, this is going to be marks of column. And now, if I do this, haha, look at that. We haven't done the useful thing to actually print which each of these are, and something is still off because I'm not seeing any pounds anymore. But that's because some of the data points are the same. So 3, 4, 2, 2, 3, 4. Yeah. So at 1 we have 2, 3, 4, and at 2 we have 2, 3, 4. This does mean there's like one observation from here, that this is how we end up with max columns, right? Is that up here where we loop over the columns, we got to say if down here, if column is, if column here is equal to, or is greater than or equal to marks.len, then it's an interesting question what we do here, because there is an argument. I think also I want to set line equals remainder up here already. Like, do we just skip if there are more data points? I think we do, right? There's no need to really crash here. It just means that if you have more columns than we have symbols for, then we're just not gonna handle them anymore. Cool. We can't label these ones. Obviously the comments here can get better. Why do we never use max X? Oh, it's just because that is a part of what's printed. In fact, let's match that print that they put at the top too. Print header, which is going to be this. Right, so they do this, and they do this, and then they do this. We don't have print counts right now. And we can do this by just doing a write line into stood out of this. And this. And this. This loop might be harder because there's a variable number of them. So I think we're going to stick with right for that one. And that's going to be min x, max x, min y, max y. And then for column in y's dot for columns in 0 to y's dot len, right? So to iterate over all the columns, we're gonna say this is right to standard out, this, and this will be marks of column. And yes, this obviously will not match Rust formatting, which is fine. What's %g for printf? No, man printf. Man3 printf. I want the C function. Percent. Where's G? Conversion specifiers. G is converted in style F or E. The precision specifies the number. Style E is used if the exponent from his conversion is less than -4 or greater. Okay, this feels like just print the number. Min x, max x, min y, max y. So that one's easy. This one is %s, which is just a string, %d, which is just a number, and %c, which is just a character, all of which we can just print easily. This one is just trying to include comma space after the first one, which we can do with if column is greater than 0, then this. Otherwise this. We don't have a ternary operator in Rust. Or we could split it into multiple writes, but that's easy either way. These are going to have to potentially error. Fine, I'll run this. Cool, it gives me that, but I'm missing a write line to std out. Cool, and now we don't need this print line we have up here anymore because we now print this the same way that guff does, right? Right? Yeah, that looks pretty promising. Although the mark is printed incorrectly. The mark should be printed as is there a character from here? The problem is this is a U8, right? Which is printed as an integer, and we want it printed as a character. There we go. Okay. We have a plot. So what's missing now is the axes. The axes, which are draw axes. And this one, luckily, is pretty straightforward. But again, we'll take the... that goes to the... This one, I guess, doesn't need to go in the canvas. Right? Because this is just separate. It could go in the canvas, but there's no real reason to. And then now up here, draw in the axes. This could happen before or... no, it actually has to happen before because, as we saw, the data points can go over the axes. So we do actually need to do those first. So this is drawing the axes. This is draw in the points. So this is just for I in 0 to h to height. If draw y, right, this is the draw y-axis that we had to figure out where it came from, which is computed over here. Right, because it needs to compute the origin as well. That's fine. So this is compute origin. So draw x-axis is going to be if min y is less than or equal to 0. And max y is greater than or equal to 0. And this is min x is less than or equal to 0. And max x is greater than or equal to 0. Let origin is origin x is that's fine. We'll stick with the code as they wrote it, and then we can always modify it later. So we're just gonna say let origin is 0, 0. If not draw y-axis, then if min x is greater than 0, origin dot 0 is min x, else origin dot 0 is max x. I gotta decode that code in a second. 7y if draw x-axis min y, 1, 1. Okay, so what does that code do? So this is if we decide to draw the x-axis, that is, if we are including, if 0 appears in the plot is really what this measures, right? So this is not really draw x, well, I guess it is draw x-axis, but it's like literally like, are we drawing the line for the x-axis in the sense of the line that goes horizontally through origin, not x-axis of the plot, but x-axis of like the coordinate system. So I think this is really draw y equals 0. And this is, okay, I want my formatting and autocomplete back, please. Thank you. I think this is more like, just because there are two different definitions of x-axis, right? It's the one you plot and the one in the coordinate system. This is draw y equal to 0. And this is draw x equal to 0, right? So the second one is draw the vertical line where x is equal to 0. And you draw the vertical line where x is equal to 0 if the minimum of x is less than or equal to 0 and the maximum of x is greater than or equal to 0. And the origin of your plot is going to be if you 0, 0. But if you're not drawing 0, 0, then your origin is going to be, if the minimum x is above 0, then you're going to draw, like your origin is going to be from 0 and onwards. And if your minimum x is less than 0, how can your minimum x be? If your minimum x is less than 0, then by implication through this, your maximum x must also be less than 0, right? So we're drawing to the left, so to speak, of the x equals 0 axis. Then your origin is going to be your max x. Why is that? Why do they care where the origin is? I guess the origin is like in that direction, but do they like highlight origin specially? Yeah, you do have to scale the origin, but like point origin. But I don't think the origin is stored anywhere here. It's stored in SP. So axis X and axis Y is going to become those. So let axis X is going to be origin.0. And axis Y, just to keep the naming that they have, but it's scaled. So that's just the logarithmic scaling, which we're not currently doing. And so that gives you axis X. So do they use axis X in here? They do. Why? Oh, I see what's happening here. This is, if you're drawing a negative plot, I think I see what's going on. Let's make these values -2 and 2, and then -1 and 1. Yeah, so see here, your axis is on the right-hand side. And so what they're trying to figure out is not really where origin is. It's where to draw the x-axis on your screen. And that's either going to be like if the x-axis is going to be in the middle of your screen somewhere because you're spanning 0, then your x-axis is going to be at some column in the middle. Whereas if you're drawing everything is like to the left of the x-axis, even if it's far to the left of the x-axis, you're going to draw the x-axis on the right-hand side of the screen regardless. And so that's why this gets set to max x if you're below 0, because you're still going to draw the axis at max x. You can't draw it further over where the origin really is. So this isn't really origin. This is like the drawn axes, but it's like, it's not in the value system either. It's like, oh, it is in the value system. So it's like in the coordinate system, what is the X value of where we're just going to draw a line? This has nothing to do with origin. I think what I want to do here is to say, this is draw vertical at is 0 and draw horizontal at. And if we're not drawing x equals 0, then we need to figure out where to draw the vertical line. And we're going to draw the vertical at the minimum x that is being displayed. If minimum x is greater than 0, otherwise we will draw the vertical at the max x. And similarly, here we will draw the horizontal at min x, and we will draw the horizontal at max y. The axis position is arguably right. And so now when we draw the axes, now we can say for I in 0 to height, if draw y-axis is x equals 0, so we're looping over the height, and we're looping over the height because we're drawing the x equals 0 line, which is a vertical line, which really means so this, I'm going to claim that this actually isn't even draw y equals 0, or it kind of is, but the more meaningful word here is like, this is like y0 is visible. And this is x0 is visible. Yeah, and now actually this reads a lot better because take a look at this now. So we loop over the height. So this is draw the vertical axis, the vertical, which is the y-axis. So where x is equal to 0. So we're looping over the rows. If x0 is visible, then we're going to mark it with, let me skip this for now. Then we're going to mark it with a pipe. And if it's not, then we're going to mark it with a space. This is the code we were trying to figure out earlier, right? But I think now it makes more sense that if x0 is visible, then we want to show a line there. If x0 is not visible, like if the axis we're showing is not actually the x-axis, we're just going to show spaces there instead, with delimiters for the for just the minor ticks. Horizontal at equals min x. Yes, that should be min y. Good catch. So this now is if I mod 5 is 0. I don't know why it's 5. That seems very arbitrary, but okay. Otherwise, this. And in fact, we could basically make our own ternary operator here that you're going to hate, but I'll do it in the else branch, which is I mod 5 equals 0, then sum b dot unwrap or b space. That's the other way to write that. It's longer and more confusing, but you can. I'm not going to do that to you. There we go. Cool. Yeah, I know, right? Isn't that beautiful? Okay, so now we have the C, and so now we're going to write into the data, into the canvas, I mean, cell. The row is going to be I. The X is going to be the draw vertical at. Something's not right. Yeah, this isn't right. Draw horizontal at needs to be scaled to match the height and width. Or is that... why do I keep forgetting whether scale point is just the log transform? It's not. Okay, great. Yeah, so we need to do the same thing that we're doing here. Yeah, and this is why we really need this to be a helper, because now this is going to get kind of ridiculous. This is going to be... h at as fraction of axis is draw vertical at minus the oof. Yeah, we definitely need a helper here because this makes me sad. But that will do it. And then we'll have to do the same things here. Horizontal. Wait. This, oh boy. This goes there, that goes there. Oh no. What did I do? Minus... Okay, I gotta actually think about this. The horizontal line needs to be a fraction of y. So that's gonna be draw horizontal at minus the min y divided by the range of y. And then it's going to be the plot height times that. And the vertical is x equals 0. So that's the vertical at minus x divided by x multiplied by the width. Yeah. Yeah, okay, great. Definitely gonna, trust me, we're gonna make this a helper. All right, so now this can be cell, which now makes a lot more sense. Cell is that, else. Panic. Where's our panic from before? Invalid cell, I, draw vertical at cell for axis component. Axis component. Wait, this isn't right. This is actually, this should be Y cell and X cell, because the cell is row column and the data points are X, Y, which is all sorts of confusing. So this is the, no, so that was right because the row is I here. Let's call that row so that we don't get confused. This is row. This is row. That's the column for axis components. And I guess we actually don't know what the Y is here because we're walking the whole gamut, right? And we're walking in terms of rows, not in terms of data values. Draw vertical at. And then we can do cell is equal to, and this is where, what does it draw for the axis? Oh, that's the C that we just computed. Great. And then we do the same thing again. Draw the horizontal, so the x-axis, so where y is equal to 0. And so now we're going to do this bit. And now we're going to walk the column in width. And if y is 0 is visible, then if the column mod 5 is 0, then plus, otherwise dash, because it's a horizontal axis. Otherwise, they use dots still here. I'm not sure whether I agree that should be a dot, but that's fine. This is now going to be not the row, but this is draw horizontal at cell row, which actually means that this is not cell. This is draw horizontal at row, and this is draw vertical at column. And now this becomes easier to read, because now this is going to be draw vertical at row. So it's clear that it should go first, and column clearly should go second, and this should be draw horizontal at. And that also means that I kind of want to rename this, because this is draw vertical at X, and this is draw horizontal at Y. And so now these match up and everything is happy. Draw those. And then crucially, where the axes meet, put a plus. So that is canvas.cell, draw horizontal at row, draw vertical at column. This is sort of this is the intersection. Else. And this one, I think this is actually impossible to fail, right? Because we've already walked all the rows and the columns. Like, we've already used these values. We just haven't used them together. But that must guarantee that they are actually valid. So here we're going to do .expect all must have hit one of the panics above. And so now we can do intersection is equal to plus with a B. I really don't like those two nested if statements. Which of them? They're all over the place. Here or those? There's a bunch of them. Okay, so now we get axes. Those are not expected axes. That's because we are this flipping of y. We gotta have a function. I totally agree. This needs to be. This needs to be draw horizontal at row. Because we need to flip it. Now we have a plot. Cool. And so now, just to see what happens, right? If I give it this data, okay, it's not quite what I was hoping for. Oh, that's because I'm currently assuming that I get X, which is not true. This is where the lack of true. The lack of command line parsing comes back to bite us. Now we fill at line 94. Now this fails. Attempted to subtract with overflow. Oh, that's because the X value now, normally we set when we found it, but if we find it because it is here, then that becomes different. We really want to call that the moment we find an X. Alternatively, we switch this so that we add the X at the end. Yes, I think that's what we're going to do. We're going to do this. So this no longer needs to subtract 1 because we haven't pushed to X's yet. Yeah. This is going to be great. So down here, if let sum X is X, then X's dot push X. So this is whatever X value we discovered is the X for the row. Note if there are no, if this is none, that means there were no column values at all, which is equivalent to an empty line which we don't count as a sample at all. Which we don't count as a sample. Simply don't count as a sample. Note also that this means Y's has not been pushed to either. Cool. Yeah, and that needs to be done before this because this fills all the Y's to be equal to X's. Cool. Now, if I do this, haha, look at that. Look at that. And the Y value here is like, what, 3,000 something? So if we do 2,000, we get a line there. And if I now go back to doing the same thing in guff, Where was this? That's pretty good. The only difference seems to be that I think they're doing some kind of padding, right? So remember, we are currently not doing the padding they're doing. And the pad here seems to be by like one column, right? Like our plot is one wider and one taller than theirs. Why is that? Why is that indeed? I think it has to be in the scaling code, right? Because it's in the scaling code where we would end up overdoing this. But it's just width minus pad, which did we not do that? Plot width. Oh, it's because this needs to be plot height. And this needs to be plot width. Oops. Unless the axes... Our axes are actually the same. So I don't think it's there. So it's got to be in the data points then. Oh, maybe it's simply here. That the scaling of that one should not be according to the plot. That's actually interesting. So what do they scale by here? They scale by... Oh, no, it's the... We don't do this. I mean, right? That only appears here. So that doesn't feel particularly relevant. But I guess it's a reasonable assert to have in there. We could do that at the points, I suppose. It would be down here where we actually plot the points. Yeah, this is now getting to the point where it needs to be refactored so that it's not all in the same place. Assert that x is greater than or equal to this. That's just an assert they have. I'm fine with that. But they scale by pad, but I don't see this show up anywhere else. Oh, that's stupid. It's just because their pad is 2, not 1. Right? I set it to 1 up here, didn't I? Somewhere. Pad. Yeah, pad should be 2. There we go. I think this is where our rounding is coming to bite us, maybe. You see how at the point where we like switch from one to the other, their rounding is different than ours. Just interesting. I mean, we can do what they do, I suppose. I'm just like I'm confused about why this matters. right? If I do width 64, so they do plus cell width divided by 2, and they do the same thing here, right? And they do that, yep, except that's cell height. And then I guess they don't round, they just cast. And then they do the same for the data. So this is plus cell width divided by 2. This is plus cell height divided by 2. And this doesn't round. Yep, now it's the same. Whoa, but the axis is in a different place. That's interesting. Was it like that before? No, okay, so I just messed up the What? How did I mess this up? All uses of cell is divided by 2. Yes, but that's what I did. Yeah, I mean, I know I can divide this by 2, but so that I don't have to do it in every place. But I'm just like, why did this mess up our axis plotting? Oh, did I get these backwards? That's probably why. Yeah, okay, great. So now the plots are identical. I just don't understand why these are different. Like, why is this different from this? I think it's a boundary condition thing. But I mean, we could easily do just like 1, 2. This is just so it doesn't break. Sure. And then I want to assert eq. Draw horizontal at row 1. Draw horizontal at row 2. And I guess I'll just print some things in addition, right? So I'll print the draw horizontal at y, and I'll print min y, and I'll print cell height, and I'll print range y, which are all the things that go into there. Oh, and plot height. What? Oh, because the rows do actually compute the same. It wasn't the rows that were different, it was the columns. Oh boy, okay, fine. So that means it's actually this bit. So these don't actually differ at the moment. I suppose I can still keep it. But it's really this. this versus that. So this is going to be 1. This is going to be 2. 2 is going to not do that and instead do dot round. And then we're going to assert equals vertical at column is going to be draw vertical at column 2. Draw vertical at column 1. Draw vertical at x. And this, now we need min x, cell width, range x, and plot width. Oh, because it's not for the axes, it's for the points. All right, fine. Let's just restore these. Store these. That's fine. That's fine. I'll restore this one as well. And then I'll grab this assertion, and I need to bring it down to where we've flipped the points. And here, it's the x that looks wrong. So XL1, XL2, how many times are we going to do this? Dot round, assert equal XL1, XL2, X, let XL is XL1. Okay, finally. 40 and 41. I mean, those are different numbers. So let's sort of retrace our steps here, right? So this is what we get out, and we get that this is 40 versus 41. So why? So x is 145, min x is 0, cell width is 3.5, range is this. So what we end up computing is 145 minus 0, which is 145. So we do 145, let's do the case with round first, divided by range of x, which is 315. And then we do that times plot width. But we do this dot round. So that's one version where the plot width here is 88. The first one is that we actually do 145 plus 3.5 and we don't round. Yeah, so it's got to be at 0.5, right? That's the problem. It's got to be. If a value is halfway between two integers, round away from 0. So this rounds up. What if I do this? Okay, that didn't help. So, I mean, first of all, what is 145 divided by 315? It is 0.46. 0.46. So that should round down. Wait. Oh no, the rounding is afterwards, right? It's not this way. It is this way. So 88 times 0.46 is 40.48, which is, so that's 40.48, which goes to 40. Whereas here, if we do 145 plus 3.5, that's 148.5, and we divide it by 315, we get 0.47. So this is now equal to 0.47. So this is now 88 times that. And 88 times 0.47 is 41.36, which is 40. Is 41. .36, which goes to 41. It's not 3.5? It's 3.5. Oh, divided by 2. Divided by 2, divided by 2, divided by 2. 145 plus 3.5 divided by 2 is 146.75. Divided by 315 is 0.4658. 4658. 88 times 0.4658 is 40.99. But that's still like not quite 0.5. I guess maybe we're hitting F64 here, but like... Oh. Hang on. This should be floor. This should truncate. Which means that this should truncate. Right? But then why is it... Oh wait, this becomes 40, this becomes 41. Why does that become 41? Divided by 315 times 88. Oh, it's 40.5. Okay. 501. 45 divided by 315 times 88. 40.5079. So it gets rounded up to 41. But it is because of the rounding, right? It's because this gets rounded. I think it's because of the rounding just at like 0.5. It's gotta be. Yeah, I think it's just a precision error. Like, which then raises the interesting question of, should we match the original rendering, or should we use the thing that's more reasonable, which is to just round? I think the right thing to do is to do the rounding here. Like the way we do it in Excel 2, right? Like it feels like the right thing to do is calculate with the most precision we have until we have to round it to an integer. I don't think you need to round twice. I think the Excel 2 is the right way to do it, because you compute, like, all of this is in F64 space, right? And then it's only when you round, then you only round once, which is the moment you need to turn it into an integer. If you want to match, you need to round twice, yes. Although, where would that rounding even happen? It's not clear where the other round happens. You can't round here because you don't want to go to an integer here because then this multiplication makes no sense. Okay, I'm just gonna go with this one because I think it is a more reasonable approximation for what we want to do. Even if it renders slightly differently and it avoids having to have these extra cells around. And then dot round. This was still using cell. I'm confused. Okay. So now we get this and they get it shifted slightly, but that's okay. All right. Fine. We now have the rendering in place. We didn't need this. We didn't need this. I don't think we're going to need this either. So I think we're good. There are a couple of things that I would like to add to this. The first is they have this option to apply logarithms to X and Y, which I think is pretty useful. The other thing that we have is they have the ability to count for values instead of using just a point. The counting is kind of interesting because I wonder where you do the counting. Because remember, we have a slightly different data layout than they do now. And I actually wonder if this would actually be easier if we did it the other way around. If we had columnar data. Again, if we didn't walk by row here, instead, or we have columnar data. So I think I would walk the columns. Oh, but you don't know the X. So where do they do the sampling for counts? Because there are a couple of places you could do it. You could do it as a pre-processing step. This is going to be the same thing if we want to compute things like PDF or CDF, because you're going to have to walk all of the points of a data set, which I guess actually is what we're doing here, right? Like we're going to walk all of the, no, this ends up walking all of the rows and then all the columns. Whereas I think what we actually want is to walk all of the columns, all of the rows for a given column is how you would compute distributions over the data. Which would mean that we would just flip this so that the outer loop is that and the inner loop is this. Because then here you can do a post-processing step. So actually, okay, we can keep this the way it is. And then I think the trick we're going to pull is here. Actually, maybe more like before we normalize the data. So up here. So this is where we read the data. And then here, we're going to apply transformations. And when we apply transformations, then we're going to do it differently. Oh, I fucked this up down here, didn't I? Yeah, this is going to be row and x's. No, row in x's. Yes. What? How did I break this? Didn't mean to break that. Row x's. I don't quite understand how I broke the code down here by changing the code up there. Oh, it's because that used to have a copied is why. That's fine. So down here, iter dot copied, and we could actually do the same thing here. Oh no, it has to be just there. And now if I go back up to here, copied. No, copied dot. There we go. What we're going to do is we're going to loop over the columns in the outer loop. Because that way the columns are just like the data sets, right? And then here, what we end up doing is walking all of the XY pairs for a given column and all the XY pairs for the next column and all the XY pairs for the next column. And we want to do the walk in this way here because it allows us to transform all of the data points for that data set and see all of those values in a row. And so now we have a couple of ways in which we could do this. I guess it's like mcount. I forget what the exact syntax for this was. It's like -m mode dot counter line, and that applies for that applies for. So we're going to have enum mode, and the mode is going to be dot or count. Mode is going to be mode count. And so now I actually don't think mode can be applied here, because mode is about counting the number of things in a given cell. It's not about the underlying data. So I actually think this might have to live down where we do the rendering, because mode is sort of an output tweak. But this is where we would apply. Let me pull this down here, I guess, so that we can deal with it later. Down here. But up here, this is where we would do something like create a histogram of the values and then change them. It gets really interesting here, though, because imagine that you want to do a histogram over, like imagine you have two data sets and you want to do a histogram over one column but not the other. You actually need to change the x-axis, because for a histogram, or for a CDF rather, for a CDF, the y-axis becomes the x-axis, and the y-axis becomes a probability. So what happens if you have multiple data sets? I guess you just group all of them, but it becomes pretty weird. I think we might have to assert, like if you ask for CDF mode, we may have to assert that there is only one data set, which is fine. CDF maybe? Cool. I'll also show you a CDF plot, so because it's a useful reference here. All right, so for modes, that goes to here. There are a couple of ways we could do this. One of them is that we actually keep like a hash map of some kind. The other is that we keep the counter in the cell. This is not something the original did, but like there's a world in which here, look, like this, it's going to be terrible, but you're going to love it. If let mode count is mode, then oh, this is going to be really ugly, but I'm going to do it anyway, just to show what it looks like. Then, and you're probably going to hate it, but that's okay. We're going to walk all of these, and we're going to say cell is equal to a 0 for all of those. And then down here, if let mode count is mode, actually we're going to do match on mode. If mode dot, then this, and here comes the ugly part. If mode is count, then cell is going to be cell plus equals 1 is going to be cell plus 1 dot clamp. No, it needs to no, it won't be plus 1 because in ASCII the letters don't come after the numbers. So we need to match on cell and say that if it's currently between 0 and 9, then cell plus 1. If it is currently 9, then turn it into A. If it's currently in A to Z, so I guess this is actually this or that. And Z or anything else actually becomes pound. No, it's dot dot. It's exclusive ranges this, so it doesn't include Z. And Z gets handled here. And pound is not after Z. Yep. That's awful. That's really awful. You don't need a hash map. What do you need a hash map for? The original. Okay, so the original. Where's the stuff? It's very cursed, I know. So they have this like, if mode is counter, they allocate this counter thing. They walk all the counters to create a counter for every column, and they count all the points. And count points here is like walk all the rows, scale the point, increment the counter, which is hashed by the X and Y value. But you can just do that. That's fantastic. Oh, you're right. We do have to change the header. The header needs to not include this. Oh, I need to refactor this pretty damn soon because this is a mess. It's down here, right? Yeah. Yeah, so this now will become this. And this becomes if let mode dot is mode. Then write tested out this, please. M count. D 90 by 25. Oops. That's D 90 by 25. Yeah, and we see this is the rounding, right? Like, because of the rounding, some of the numbers shift around for us. Like, if you watch this area down here, it's kind of interesting. That's a 4 here, and it's a 3 and a 1 for us. This is a 2 and a 1 there, and it's a 3 for us. The next is a 4 for us and a 4 for them. And then it's a 3 for us, but a 4 for them. But the next is a 3 for them and a 4 for us. So I do think it actually adds up. That's glorious. But the annoying thing, right, is that we need to compute the positions twice. Which we can avoid by... So the reason we need to do this in 2 rounds is because the value of a cell might be like space, but it might also be like the axes ticks, right? And so you don't really want to just loop over and do the logic we had below for arbitrary current values. The only exception would be, and this is maybe even more cursed, is if we did this, and we did anything else. It's like axes and such becomes 1. Then I don't think you need this. That only works if the things we use for axes and the background are never letters or pound. Which I don't think they ever are. So we're fine. But that's way more brittle. But it does work. It does mean we don't have to do it in 2 passes. Cool. It's quite... This is like a curse on top of a curse. Right? Like, it's cursed to do the counting in the cell. And it's doubly cursed to just like assume that anything that's not any of these just is going to be 1 now. Okay, this at the very least deserves a comment. In count mode, we want to display the number of points in every cell. We want each cell to display the number of points that fall within that cell from any data set. We can get this behavior by abusing the U8 that gets stored for every cell. We simply use that U8 as a counter. Counter in base 36. Counter that saturates in this part is cursed. is extra cursed. Yeah, I mean, it's true, right? Like um, we could not store U8s in cells. We could have this be like either an enum of blank or character or count or point, I suppose. The downside of doing that is this printing later becomes way more annoying because now you actually need to not just loop down, you need to loop across the characters and print the characters one by one, which isn't the end of the world, but like this is fine, right? Like it's not, we control the code above. Something needs to initialize the U8 base, the US base 36 counter. Sorry, not sorry. To initialize, we could do that with a loop before this one, but doing so would mean we also need to compute all the cell values multiple times or cache them somehow. Something needs to initialize the U8 base 36 counter. Because their previous value could be space. I guess I should really make this be in single quotes instead. It could be space from the blank canvas plus minus dot or pipe from the axes. We could do that with a loop before this one that sets every data point cell to 0, but doing so would mean you need to do the multiple or cache them somehow. Instead, we simply assume that any non-base 36 and not pound value is 0. Yeah, it is base 37. It's like base 36 that saturates to pound. Okay. Dot is never constructed. That's fine. That's going to come in once we add argument parsing. And then for this transformation stuff, I think it might function similarly to count, where I suppose count is really just about the visualization, right? It doesn't actually change the way you plot the data. So let me show you a CDF because it might be instructive here. Cumulative distribution function, right? Cumulative distribution function. So a cumulative distribution function looks kind of like this. So the values on the x-axis are the y values of the data set, and the y-axis is the percentage of values in the data set that have that value. So imagine that you have a data set that has like an equal number of 1s, 2s, and 3s. What you would see is a step function. So you would have 0 all the way, like the plot would, imagine it goes in infinite directions in x. It would be at y equals 0 all the way until you get to, I said 1s, 2s, and 3s, right? So all the way until it gets to 1. Then it would jump up with a step function up to 33%. So what that's saying is 33% of the data is of value 1 or below. And then it would be a flat line at 33% until it gets to 2, and then it jumps to 66%, saying 66% of the data have a value of 0 to 2. And then it would be constant at 66% all the way until it gets to x equals 3, and then it would jump to 100%, saying 100% of the data is contained within, is up to the value 3, and then it goes at 100% forever. So the nice thing about this is it lets you see how your data is distributed. It lets you find the median. So the median would just be at y equals 0.5. The x-axis value there, that's your median. Your mean you can't get from this plot, but your median you can. Because the median is saying 50% of the values are of 50% of the values are of this value. And they're also handy to see things like, do I have a long tail where there's lots of values that either are very small or very large, so I don't quite get to 100, or it takes me a while to get to even 1%. So CDF, super nice. And PDF is the same thing, except that it's not cumulative. So it's just the instantaneous percentage of the values. So if let's say x equals 0, you would get, if you saw at x equals 0 is 50%, that means that 50% of your values are 0. So it's not below. So CDF is cumulative PDF, if you will. At least unless I've gotten that wrong. So the thing that gets weird here is, imagine that you have multiple data sets. So if you have multiple data sets, they're going to have different y values. And the x values kind of don't matter here. I think for a CDF and PDF, you just have a bunch of numbers. They don't really have x values. You plot a distribution, you plot the statistic over a distribution of numbers, not a distribution over pairs of numbers like x, y. And so I think the way we would implement this in practice is that we would say, you cannot use this with the -x argument, right? I think we would say that because the x values don't really make sense. It should just be a single set of data. And where it gets weird is if you have multiple data sets and they happen to have different ranges of y values, then you would end up with these sort of nice curves that you get from CDFs, but they would be offset relative to each other. So one of them might go from -5 to -2, and one of them might go from 1 to 4, right? And they would both be this distribution between 0% and 1%. They would share a y-axis, but they would be offset in x. And I think maybe that's okay. It's just weird, right? Because you have a plot where you don't have numbers on the axes either. And we could probably add those. The PDFs have the same problem, I think, right? Because the x-axis is the y-axis of the data. They are stacked here, yes, but the nice thing here, right, is that they are plotted over the same distribution. So they all share an x range. That is, they share the range of the original values. And so therefore they end up sharing the x range here. That would not necessarily be the case for different data sets. Although I suppose it could be, right? That's really just up to the provider of the data. So I think this is fine. I think what we're going to do here is and I actually think the other thing we would probably do here is to say that count mode is forcibly enabled when you use CDFs. Maybe. And the reason I say that is because that way you can see where lines cross. Right? Because where the lines cross, but you wouldn't be able to tell them apart if they don't cross. I think what I really want is a count mode that... I want a count mode where if the value is 1, you use the mark. Yeah, only count on overlap. Which, you're going to hate this even more. Which we can do because we know what the values are here, and we can say that they must be distinct from these. It would mean taking pound out and plus minus dot dash pipe. None of those are in there. Right? And so then what we would say is that so dash or plus or dot or pipe or space turn into marks of column. We want non-overlapping values to keep their mark, so different data sets can be told apart. So 1 is marks column. This in turn requires that none of the axis marks are in marks. And then here we would say see if marks contains C, then that would become 2. And anything else is actually a panic. This should be unreachable because this is saying cell at held unexpected counting mark. Right? Cell at, and this is like what, row and column. So this would be Y cell and X cell. Interesting. I mean, that works. It's a little weird, but I think it's okay. I think that's an improvement on mode. And then now what we can do for CDFs is I think we'll say CDF is true. And I think when CDF is true, it's going to force the mode to be count. So what we'll do then is we'll go down here, we'll grab our mode definition, because that's really going to be configuration up here. And that's going to be dot. But if CDF, then mode is going to be mode count. And we can also say that that goes up here. I don't think CDF is a mode, because the mode is like a print mode. It affects your drawing. Whereas CDF is more like, it's more like a scale transform like log, except it transforms your dataset as a whole, as opposed to converting your dataset value by value. It's not element wise. You're already using star. Maybe that can be the saturating mark instead. Star is in there, yeah. So I think what we'll do here is, this is also where we could do log, right? Like we could implement log in this too. So the interesting bit here is also going to be that our x's are going to completely change. Right? It's going to be like if CDF, then we're going to completely overwrite x's. We're not even going to loop over x's here. What we're going to say is actually that x's is going to be copy from slice, and we're actually going to say const yeah, this is going to be interesting. So I think what we need to do is we need to construct a histogram for each one. So here we're going to do cargo add htr histogram. So we're going to do histogram is histogram new. And we'll do, is there a default? I forget. There might not be. Histogram dot, and there is not. Okay, fine. 5. I don't remember what value to use here. Histogram dot, dot expect. Valid. 5 is a valid sigfig. We should probably pick this more reasonably. What's the lowest discernible value of 1 and an auto-adjusting highest trackable value? See new with bounds. New with bounds. Upper and lower bounds for recorded values. Oh, well, we actually know those, don't we? Right? Because these are going to be the min and max y from the data. In fact, all of these values are going to change once you do a CDF, right? So we might as well compute them before, and then we may have to recompute them after, but that's fine. So this is going to be that. So I can actually do new with bounds. Oh, but HDR histogram doesn't do floats. It only does integers. That doesn't sound right. I don't think it only does integers. Right? Now I'm unsure. Record. Does only take integers. Well, that makes things awkward. The doubly awkward thing is that I'm the one who wrote HDR histogram. So I should have known this. It might be the case we want to compute the CDF in canvas coordinates. In canvas coordinates? Why? No, that doesn't seem reasonable. I mean, it would give us integers, but I don't see why you would do it in that space. It would allow us to do it with a histogram like this, but like you lose a bunch of fidelity that way, but maybe that's okay. Yeah, it's true. Histograms for floating point numbers are weird because you can't really define the bins meaningfully. So we're going to lose the resolution regardless. I agree with that because when you plot, that resolution goes away. But like this is similar to the round thing where I'd rather lose the precision later than earlier. But we might not have a choice. This is where it gets a little awkward too, because if we want... we're basically going to have to do all of this computation first, right? And then we're going to have to compute the CDF, and then we're going to have to compute all of this stuff again. Because we're changing the X and Y values, which is okay. It just means that this is a little less trivial. And I actually think we want to do the refactor first so that we have a way to do this recomputation by just like calling a function. So let's maybe do that next. Let's, yeah. So we're going to set this to false for now. If, cool. And then what I'm actually also going to do is I'm going to go back to this. I'm going to get rid of this dependency. Cargo check. And then source main. Get rid of this. That's not there. That goes away. Okay. Add dot commit a thing that does a thing, you know, in the interest of MacGuffin and Dinks. All right. Let's start to split this up. Let's maybe get some proper... I think I maybe want to split it before I start adding... I think I want to split it before I start adding command line argument parsing. So... what are the modules I want here? I want... I think I want canvas in its own. I think I want... I think I want... I was going to say maybe I want scaling as its own, but I'm trying to see what this would look like. I'm fine actually with the input parsing just living in main. But that would mean at the end of this loop, so this is after we've computed all the inputs and we have the columnar vectors. What follows? Well, what follows is computing of the computing of the ranges and the axes, which I would call something like a frame or a viewport. I think frame might be right. So the frame would be responsible for computing the what is the X and Y ranges that we're plotting, and where do the axes go in the plot. And then next thing that's needed is a way to scale values. And I think the way you scale a value is that you give it to a frame. Yeah. I think you have a frame, and the frame knows the sort of domain that it's plotting in the coordinate system, and it knows what the axes are. And so if you give it a XY coordinate, it can tell you the XY cell that would correspond to. And similarly, the drawing of the axes is something the frame can do into the canvas. And then the points, I think the points live separately from the frame. But where do they live? Arguably feels like it could just be a function in main, but it's like maybe we should have a data sort of container that main populates the data into, and then it has a way to plot itself into a canvas. Yeah, let's do that. Let's do mod data. I don't know if I like mod data yet, but we're going to create that. We're going to create that. We're going to create that. Canvas is easy enough because canvas we already have. Pub create. Use, this is also incorrectly named. That should be canvas. Cool. Use canvas. This I think can actually remain a pub here. Frame is going to be a pub create struct frame. And it is going to know its min x, its max x, its range of x, its min y, its max y, and its range y. Like, arguably it doesn't need to keep those separate, but let's do that splitting in a second. And on a frame, I think it also needs to know its own width and its own height. And one of the things it needs to be able to do is draw into, and that's going to take a canvas. Yeah, and I don't think it implements from data because it only doesn't need to own the data, but I do think it implements new over. So it's the width, a height, and a data. And then this is going to have a pub create struct data that we haven't quite figured out yet. This needs to import create data data. And now we can pull out here this stuff. So this is going to be data.x's, data.y's. And we're going to give this now x's is going to be vec f64, and y's is going to be vec of f64. And for now, we'll make these pub crate. We might make accessors for them. That's fine. So that's going to compute this. It's also going to do this stuff. We'll have to figure out what to do with these early returns. Because these early returns are like, if there is no data, then what does it draw? Yeah, we'll have to figure out what exactly goes there. I think it's going to be a to-do, and this will be a to-do. This is no longer really origin. This is figure out where to draw the axes in the frame. And this might even be a thing that happens on draw. Might not need to be computed when you first get the data. Yeah. I think that's right. I think here we're actually going to, on draw is when we're going to do this bit. That's going to go in there. And then this is now going to return self with these. And then this is now going to be, it's going to take self. So this will be self.width, self.height. This will be a const up here. This will be self.min, self.min, self. Yep. And then we said that the frame was going to have a method for doing this computation, right? So there's going to be a pub crate probably, which is going to be a point to cell, which takes a point in f64 and gives you back a usize. And this will be actually, I kind of want to grab the other one because it already has better naming for these. This, except this will be X and Y. And this will be row and column. And then this will be, so this isn't, yeah, and this will be Y cell, X cell, because it's going to be row column. This will be self.height. But there's another bit that's interesting here, which is, where did plot height go? Plot height and plot width go in here. Like so. So that computes a Y cell and an X cell. And now these guys over here, this can now become way nicer because we can say draw horizontal at row is going to be self dot point to cell of 0 and draw horizontal at Y row. And similarly, draw vertical at column is going to be draw vertical at X with a Y of 0. And we're going to pull out the column. And these need to be 0. Okay. And we're still in, this is still in draw, right? So we can now draw these. These look very similar, but I don't think it's actually trivial to share between them. I actually think I want to keep them separate. I think that's going to pay off. To simply have them like this. And this will be self.width, and this will be self.height. Okay. So here, I suppose we will say, let mute frame is frame new over with height data. Where we don't have data yet, so we're going to say here that our data is a data default. Data, you can derive, debug, and default. X's goes away. And now this will be data.ys. And here maybe we could have some helpers on data to make this, to tidy up this logic a little bit. But for now, I'm doing it a fairly straightforward transformation here. Like so. Nope, there. This will be data.ys eventually. This now has data. Great. And then points is going to be a function on data. Draw into, and it's going to draw into a canvas using a frame. I think. So this is going to be self. Then this will be, so we were doing a sort of optimization here. We're computing the cell for X and the cell for Y, like the column for X and the row for Y separately because we only have to compute the column for X once. The optimization, the optimizer might actually just catch this, but I suppose we can do a, here, we could do X to column. right? And we could do a, so that will just do this. And similarly, we'll do a y to row, which just gives you this. And that will do height and these and this. And then point to cell just becomes self.y to row of y and x to cell of x. And now we can preserve, what? Oh, x to column. And now here we can say x, it should really be column, not cell, but let's name it cell and then use rename, is going to be using dot x to column of x. Self.wise using, I don't know if I really, it's kind of weird to have this assertion here using data from frame, but we'll figure that out in a second. And then let y cell is going to be using dot y to row of y. Oh, I guess the mode needs to be passed in somehow here. I wonder if the mode is actually a property of the canvas. It's a little weird maybe, but let's say that it's a property of the canvas for now. Might move out of there. So that's going to be debug. I could make it implement default too, actually, and say the dot is the default. So mode is mode, mode is mode, is mode is mode, is mode, is mode, is mode. Pub create mode. Right, and also here pub create mode and import mode. And stick the mode in there. And now in data here, we should now have access to the mode, which is going to be canvas.mode. And import these. And I think the marks, I guess those do kind of belong in data because they are properties of the data set when we display them. Ooh. Unmatched. Where? I've done something wrong. But what have I done wrong? Oh boy. I don't know if we even need this assertion, but I'm more trying to figure out what I broke. Oh, mode can also be, no, can be copy and clone. What? It's borrowed. Canvas is borrowed here. Ugh. Fine. Silly bar checker. It's because cell takes a mutable reference to self to the whole canvas and doesn't know that that only borrows the cells and doesn't borrow the mode. That's fine. But I still don't understand why it's unhappy with me. Maybe it's just confused. This, all good. And then data points is going to be, so we'll do frame draw into mute canvas, data dot draw into canvas with the frame. I suppose the frame should really be the printer of this, right? But it doesn't draw that into the canvas, it just prints it. Yeah, I'm torn here. Oh, I suppose we can actually implement display for canvas, right? Because that's kind of what it does. Impl format display for canvas. Yeah, give me those. And that's going to be for row in this f dot write all right line f. Okay. What? I'm not allowed to write bytes into a formatter? That's interesting. So is there not a... But so the problem with write is that this will end up being format write, which takes a format string, but I don't have a reasonable format string here. Is the problem. Like if I just do F and row, I don't think it'll let me. Yeah, because you need a format string, and then I would have to do this, but row is a slice of U8, which doesn't work. And so I would need to do like I would have to do a std string from UTF-8, which I don't really want to do. So now the question becomes, is there a an format? Is there a Rust format string specifier that lets me print ASCII? Is what I want to know. Formatting traits. Nope. Unless, no, binary is different. I'm really not allowed to write bytes into a formatter? Yeah. This is where we're going to do a good old Google search. Rust byte string ASCII display. Of course it's a crate. Display bytes. Thanks. Yeah, but I don't want to... Could be this is something instead ASCII. No. I was hoping that there was like a nice... Just assert this as ASCII, but I guess that really just means treat it as UTF-8. Now, do I want to do this unsafely? I know it's ASCII because that's what I wrote in there. But I suppose, fine. I don't like it. I don't like it one bit. So now back in main, I should be able to now right line stood out canvas. Right? Yeah, okay, good. And then these mins is like, it's a property of the frame. So I guess the frame can make those public, but I don't want people to modify it. So we're going to go ahead and do accessors for them, or fn min x, or I think I'll do this actually. So this is going to be self.min x, self.max x. I guess this could be x bounds. And then this is y bounds. And so now I could do here, min x max x is frame dot x bounds, and y are y bounds, and frame doesn't need to be mutable. And what? Oh, right, I commented this out. Min x max x is frame using dot x bounds. Okay. Still plots. That's good. So now we have a much better separation here at least. Right, the main now is just like processing bits from standard in, potentially applying transformations, although we haven't done that part yet, creating a frame, drawing it, and printing. Those all feel like main tasks. The only interesting bit that's left here is that this parsing, we might want to do... we might want to do this parsing over something that's not standard in, but I don't think that matters too much. I think now... Commit. Organization for the win. I think now I want to try my CDF thing, which is then going to be, we do all of this stuff, right? We do all of this stuff rather. And then we get assert x is row. I guess I'll set this to true as well. So for the CDF, we're going to want to if we're gonna do the thing we planned of doing it in canvas space rather than in the data space, then I need the min and max in that space. And I think I'm just going to do that globally. I could do it for each y separately, but I don't think I want to. I guess for maximum resolution, that's what I would do. But the translation to space is global for the canvas. So it has to be here. So what we're going to end up with here is min y and max y is going to be frame.yBounce. And then we have to convert those. So frame.y to... Here's the other thing that's weird, right? Is that we're actually changing the plotting space. This is going to give me y as a row, but we have more columns than we have rows. So I think we have to rescale the y values here to be in accordance with the width instead of the height, whereas normally the y is according to the height, which is a little awkward. I mean, we could do it as a one-off, right? So if we go to frame, it's really just this conversion here, right? It's this conversion. But using, oh, this will be weird. It's like, I want to do this for, okay. No. I do want to use the width. I want to use... Oh, I guess actually, I don't need to do that. I know that min y will map to cell 0, and I know that max y will map to the last column. So I think I actually don't need to do this at all. All I need is the plot width. The padding here is weird to me because the padding is from the top. So the padding is just from the, it's just relative to the axes, right? So you end up with, yeah, you just end up with a pad there and a pad to the right. So I think what that means is when we do this, the bounds are actually going to be zero to width And what is significant figures? The number of significant figures to maintain. This is the number of significant decimal digits to which your histogram will maintain value resolution and separation. I think that almost doesn't matter, right? Like, it depends on the width. The width is like at most 120-ish. Like, no one's going to use 1,000 as the width. So I guess 3 significant figures is probably fine. So 3 is a valid sig fig. And then what we're going to do is we're going to loop over the values in y's. And in fact, I think histogram has like a record. Or apparently not. Okay. So we're going to do histogram dot record. What's record correct again? Coordinated emission. There's no coordinated emission, or we're going to assume there's no coordinated emission here. And what is saturating record? Clamp to the range of the histogram. That shouldn't matter. So we're going to record the Y cell. The Y as future column. In the Y as future column, this is where things get a little weird, because this is where we need to do this conversion, but we need to do it with Y minus min Y. Min Y max Y frame dot Y bounds. And range, so the range X is, oh, we do actually need to get that, huh? Okay, that's fine. That's fine, that's fine, that's fine. So the range, this one's a little bit of an abuse, but let's do that. Range, let's call that range XY. So we're gonna do let range Y is frame dot range XY. So now we have the range in Y. So this is Y as a fraction of the axes, but then the Y as future column is that fraction, but multiplied by the plot width, not the plot height. So that's going to be the width. Right, so this is taking Y, computing it as a fraction of the range of Y, and then scaling it to the plot width instead of the height. The only way in this which this gets weird is if moving it from being Y to being X is not symmetrical. Like if moving it changes what range is going to be used. And the only way I can think of that happening is for this part, which moves us to 0. And we're actually going to want to disable this potentially, because for CDFs, you don't really want to clamp X to 0. Oh, maybe you do. Maybe you do. Okay. I think we keep it for now. So it would only end up stretching things anyway. So now we record all of those over all of the values here. And once we've done that, we now want to loop over and gather, we want to sample points on the histogram. And this is where we have to, for X in histogram dot, how do we want to iterate through this is the other. I think we want to iterate through the quantiles. Quantiles, this is like an interesting thing, right? You have the bins of the histogram. How do you want to walk the bins? Because HDR histogram, one of the things it does is the bins aren't linearly spaced, they are exponentially spaced, kind of. So you kind of need to decide how you want to walk them. So that's why there are multiple of these iters. So you can iterate through them at logarithmically incrementing levels. You can iterate through all the values that have been seen. You can iterate linearly through in the Y space, which I think is what we want here, because I think we actually want to sample basically just at every rendered cell. Because that's the best resolution we can get anyway. Yeah. Yeah, let's do that. Interlinear takes a step. And so the step here is actually going to be 1. We're going to step by 1 from 0. That is going to give us a bin. And then this is where this gets interesting. So I think here we clear this Y. And then as we walk the bins, we push to Y the percentile of that bin. And so we're going to do that for every column. And then finally, we need to fix X. And X here is going to be the columns we walk over, which should hopefully be the same for all of them, right? So I think we should here be able to say that data.x's is going to be, we're going to clear it, and then we're going to extend it with 0 dot plot width. Right? Dot equal plot width. And then the other thing, just as a sanity check that we'll do here, is we're going to iterate over x's, and we're going to do this dot zip with x's dot iter. And what I wanted to do here is assert that the bin whatever, bin dot value iterated to is equal to x. Right? The value iterated to is equal to x. And this here is going to have to be, is actually this, but mapped, because this is a column, and it has to be the column as F64. And we want to check what the values, the x values that we get out of the histogram are themselves, like they sort of match the x's. The only place where this will get awkward is that the histogram, because it is not a linear histogram, it's a high dynamic range histogram, the bins are like not evenly spaced. And so it's not clear that we're going to get necessarily back exactly the same value. So I actually think this won't be quite right. I don't think we get to set x's like this. I think we have to derive it from the values we iterate over. Because it could be, for example, that there is no bin for cell 4. That there's only one for cell 3 and 5 because of the nonlinear sampling. Oh, this needs to be intermute. So I do think we need to gather the x's, and then we better check that the x's are the same. So I think the way this will look is we'll clear this. And then as we walk through here, let mute should push x. Let should push x is data.x's.is empty. So if should push x, then x's.push bin.value iterated to. Otherwise, assert equal bin.value iterated to is equal to bin is equal to. Okay, so this is where we're going to do enumerate I is equal to x's of I. This is not going to zip over that anymore. You need to clear the y's after the loop. I don't think that's true. I'm modifying the y's in place. Value iterated to. So the first y we walk, we're just going to push the x's that we iterate over. If we have multiple data sets, though, we are going to check that walking the bins for the second one will yield us the same values as the first. And I don't know that this is guaranteed if they have different data points and stuff. So, I mean, let's just see what happens. Right. Why am I not getting compiler errors anymore? Did I do something stupid? Main 105. Data? Where is pad? I'm confused. Oh, pub const pad. Okay. Main is unhappy at line 120 because this should be data.x's and data.x's. 108. But like, why am I not getting compiler messages anymore? I don't understand. Expected U64 found U size. That's fine. That does mean that this needs to cast to U64 as well, which is fine. 110. Right, this is the rescaling, which we can really just do this. So we get the Y. 120. Put F64. Right, so this is where the U side needs to be turned into an F64, and this needs to be turned into an F64. And 107 is unhappy because we need to choose our counter here. So this is the what type to use to count the number of values in each bin. I think this can just be U size probably, but let's do U32. And then it's unhappy at 116 because, well, we don't need this guy. And at 106, we don't need the column. So this can just be this. And it's unhappy with me because, because this needs to be that. But that shouldn't matter. YS moved here. Oh, I need a reborrow. That's fine. 113. This is unhappy because value is in range. It should be because we already constructed that to be within width. The low value is not allowed to be 0. Cool. That just means this needs to be with, we're just going to have to increment all those values by 1, and then we're going to have to do this -1. That's fine. Oops. No, go back. I think we'll then do let x is this, but minus 1.0. And now this can be x, and this can be x. I think you could do y is a drain. That's true. I don't think it matters really, but like, is that clearer? I don't know if that's clearer. But all right. Oh, it failed, but it failed somewhere interesting. Do me a favor here and debug print data. Because I think this suggests that it ran. Yeah, look at that. X is now from -1 to 87. Oh, right, these are columns. But how could that be? How could that possibly? Oh, it's because we record this value as 0, but this needs to be +1 as well, so that when we subtract it here, it makes sense. Okay, so x... What? What? I'm recording values that are +1. So the integrated first value must still be 0. It still will be, right? Oh, the first non-zero discernible value. No. Oh, I see. Okay, so they can still be 1. Okay, so in that case, we will do this. We'll get rid of this, and we'll get rid of this, and we'll get rid of this. Is it happy now? Okay, great. From 0 to 88, the y's are those values, and then right, and because this is a constant value, the CDF just goes immediately to 1 when it hits that value of 2000. Although I feel like that should be beyond. Oh, this is where it gets a little awkward because when you walk the CDF, once you get to 100, you don't get more samples. And so imagine that you have a distribution that like we have here, where it goes to 100 at like 2000, but the other data set has points that go to like 5000. So there are more X values that need to be put in there for the one that stops at 2000. It needs to be sort of held at 100. And so I think we need to add to this 2 things. First, we need to extend X. Yeah, we need to extend X here if it doesn't already have a value. This is the reason why the X's can differ. Oh no, but it's interlinear. Does interlinear... The iterator terminates when all recorded histogram values are exhausted. Yes, I think what that means is we might have to keep walking. And we might also walk farther than in the previous one did. So should push X actually has to be if I is greater than or equal data.xs.len. Because we might have to push more values onto X because the previous iteration stopped early. But we also might need to iterate further because there's further to go. But that can only happen here. And so this is actually the same thing we did in main, which is we need to do this extension down here. So for each Y, while actually this can just be y.resize. New len is going to be data.xs.len, y.push f64 nan. And resize will shrink if x's is shorter, but it shouldn't be shorter because we extend it from a y. But it will extend it with x's, or it will extend it with values of this value, so nan, so missing data, all the way until the end. There's an interesting question here whether we want it to be gaps or whether we want it to be line, but I think we want gaps. That's not quite right. But I think we're getting there. I think the reason that's not right is because we need to recompute the frame. Because we've changed all the data. So here we need to say frame is new over the updated data. Because if we look at the data here now, I think this data is now reasonable. So it goes from 0 to 88, and there are a bunch of y values for the first data set, and for the other one, it's 0, it goes to 1000, and then has not a number. Ooh, that's pretty nice. Okay, so what we see here, right, is this is the CDF for the right. If we didn't CDF it, remember how it was like a power law distribution, so it was like looked exponential. Well, this is the CDF you get when you have data like that, is that the a lot of the values are the same. near down by the bottom. And this is actually hard to tell from the plot, but if we go back to the non-CDF data, right? So we set this to false. If I now plot this, so you can't actually tell, oh, maybe if I do count. So there's quite a lot of data down here, right? Like we see a lot of 4s, some 3s, same here, but there are a few data points over here, right? So most of the data points are down in this area down here, which has a pretty small Y span, right? Like the Y span here is from 0 to 3000, but that means that a lot of these values are the same. Basically, all of these values are the same. They're at the same Y value as far as this compression of the Y-axis is concerned. So all of those are, like, in fact, if we look at the other plot from earlier, you see that this tells us that the median value, if you look around the center, should be around whatever this value is. And remember, we don't plot the axis values, so it's hard to say. But this tells us that, like, the median value is some relatively low number. And that matches this, right? Like here we see that the values down here, this is like the median-ish is right around here. And there are very few data points that are up here. And that's also what we see with the CDF, that like there are quite few data points here. We're quite close to like 95% of the data covered when we get to this value. And then there's like a tail because there's some really large values at the end. The other thing that's interesting, you see the 2 here? The 2 here is because there is conceptually a single line that runs here. This is when the data set that just has values at 2000 goes from 0 to 100%. And so it only intersects right there. And so I think this actually is right. The only thing I wish is that we had got a line here. But there isn't really a way to plot, like this plotter does not take into account like vertical lines. It doesn't have a way to plot them because they would have to have the same X value, or they would have to have very similar X values, but not the same X value. And that we do actually have that in the data. We just don't have it in the histogram because we normalize to cells. So this is actually a thing that would get better if we didn't use cells. Maybe we could use half cells. No, everything to the right won't have 2s at the moment. The stars are the second series. But then they shouldn't be here. There shouldn't be any values here because those should all be nans. Oh, or maybe we actually... Oh, I think we just ended... I think this is just wrong. I think we currently end up plotting nans. Yeah, if not y dot is finite, continue. That's just wrong. Which you only see when you do a CDF. Boom. So you see it stops there. It is interesting, right, whether this should expand to the last value. We could easily do that so that it extends, but a CDF is normally supposed to be more like it stops when it's no longer there. But sure, we can do that. That would just be that here we do y dot last dot unwrap or f64 and yep. So now we get that. The sad thing though is we don't get a line, and that's because we only sample once per x-axis tick. But we could actually solve that by doing 2 times the width, oversampling this as 2 times that, and then when we get these x's back, we will do the integer value iterated to divided by 2.0, I think. 2 times Yeah, so we get slightly more resolution in the data. And in fact, we could make this arbitrarily more densely sampled, right? By doing this. We just get more points. I was hoping we would see a line because you would get oh, I guess you don't get any Y's in between here is the problem. And we're not drawing lines. So you do get better sampling, but I don't think it's meaningfully better sampling because we don't draw lines. Cool. Diff. We have a bunch of dependencies now, which is a little sad. Can plot CDFs now. Can we remove that tail by properly setting up the frame? I'm not sure what you mean. Yeah, I think it's right. I think it's better to keep it like this. I think that's right. Cool. Yeah, I mean, now you see the frame top gets correct now too. I guess we still have the debug. I should get rid of that. Amend. Yeah. Cool. Okay, so we now have a plotter. It supports mode count. It supports CDFs, which weren't originally supported. It doesn't support log yet, but that should be a trivial transformation, right? Like if we said, you know, let log x log y. This should assert that you're not log x, because that doesn't make any sense. And I think it should also not log y. It depends on whether this is apply logarithm to the values or apply logarithm to the plot, right? And in either case, I suppose we could allow log y. Log y is interpreted as log of the input, not output. Right, and now if I go back to this and I say I want to plot log y, right, then we would just say, honestly, we could do the logging here. I forget with guff if there's a h. Oh, this flip x and y we don't support yet either. Log any of x, y, or c. Or you can logarithmically scale the count. That's weird. I feel like it should really allow you to set, I want to log this particular column, not all of y. But that suggests that you're actually logging the output, not the input. But in either case, this is easy enough to do, right? Because you just do v is if, actually, I guess it'll be faster to do it here, right? So if log x, then x, then for x in mute data x's, x is x dot log. And if log y, then for y in y's dot iter mute dot flatten. Yeah, we'll do log 10. Yeah, and now it's log y. Interesting. Although there was one bit of code in there that was like for the scaling part. I think There was like a special scaling for it, which was, where's scale? Oh yeah, if it's equal to 0, then 0 otherwise. If it's not equal to 0, then this. Similarly here. Although I think what's also interesting is that there's also this... there's also a question about whether you need to scale the axes separately somehow. Right? You could imagine... Oh yeah, I guess we gotta print. That's fine, that's easy. We also don't have to test for this yet, I realized. Yeah, that's just in the printing, okay. So down where we print this, if log x and if log y and log y. There we go, log y. And similarly, I guess we also have log x, but it's just the row, so it doesn't really make any sense. Cool. Okay. I think we now have all of the bits that like seem like they're annoying. There's like flip and stuff, and there's log on the count, which is a little weird. We don't have SVG, but that's fine. And we obviously don't have actual command like argument parsing, but I think that's okay too. I think that's actually where I want to stop. Support log. This is a tool that I think I want to keep fiddling with. Like I'll post it to GitHub so that it's posted there, but I'll probably keep fiddling with this and like post and share it somewhere. I feel like there's a bunch of stuff that could be added here that just make it nicer. Like for example, we have terminals now that can display colors. So rather than use different symbols, we could actually use colors in addition or instead of. So there's a bunch of interesting to-dos, not to mention the feature parity with guff. But yeah, I think we're going to stop there. This was, I hope you see that like the intent of this was to be a little less like on something that's on you're like picking up an interesting technical problem at the same time. Like this is mostly just the code. Like it's interesting because it's doing something fun, but it's not like the contents is not hard. It's only the code. So hopefully that's a useful split. Are you going to accept merge requests if someone wants to contribute? Possibly. I don't see why not. This feels like a tool that I have. It's not important to me that I like have written all of this myself. So I will probably like when I post it, I'll start looking at merge requests and stuff. I don't know how much time I'll have to actually review them, but you got to start somewhere. Cool. Oh yeah, this is also potentially a good place to start if you want to fiddle with some code and you've been following along with this. You now know all of the code. You've seen me write all of the code. So now is a good time to like fiddle with it. Add whatever features you think would be fun to add. This is a good way for you to just like play with Rust yourself. Okay, that's all for today. Thank you all for coming. And I don't know when the next stream will be, but I'll make sure to let you all know through the usual channels. So with that, I think we're done for the day. It was wonderful to have you all here. Let me make sure that I have this right. Yep, that's recording. Good. So I'll see you all on the flip side, as the cool kids say, I think. See you, bye.